Elaine in now.
All right, good morning. Welcome to day 3 of improving scientific software. We're starting off this morning with a tutorial from Reed, Miranda, and Elaine from Sandia National Lab. So go ahead, take it away, Reed.
All right, thank you so much. So title of today's tutorial is Productivity and Sustainability Improvement Planning, a lightweight method for improving your software practices. My name is Reed Milewicz. I'll be leading the tutorial today, and Elaine Raybourn, my colleague, and Miranda Mundt are also here to help out with the tutorial. So the format of today's tutorial is this. So what we're going to do is we'll start off with an introduction to what Productivity and Sustainability Improvement Planning is, or PSIP. We'll have an exercise involving an online survey that you can fill out, and we'll have a discussion on software practices, how things are done on different people's teams, and then we'll come back from that breakout and have a recap of what was discussed in each of these meetings, each of these breakouts, and then we will have our 20-minute break. When we return from the 20-minute break, we'll then dive into progress tracking cards, which are the principal tool of the PSIP toolkit that we'll be discussing. We'll do another breakout where you'll have an opportunity to construct progress tracking cards. And again, we'll debrief and then conclude the tutorial. Now, if you have any questions during the tutorial, feel free to ask them in the chat. Elaine and Miranda will be monitoring the chat. And with that, we'll go ahead and get started. So the focus of today's tutorial is on a method for software process improvement that the Interoperable Design for Extreme Scale Application Software team, the IDEA's ECP team, has developed and applied with numerous teams across the exascale computing project. And it is a practice for 1, realizing process improvements without disrupting current development, and 2, mitigating technical risks so that you can develop software with confidence. And what we're going to do today is we're going to introduce PSIP and progress tracking cards, which are the main tool in the PSIP toolkit. And then we're going to show you how you can apply these tools and techniques to your own project. So to start, today's tutorial is really about software process improvement, which concerns techniques that assess, design, and realize effective development processes. This is a topic that we're very passionate about, and it's one that's increasingly important for the scientific software community. So what we know about scientific software today, 1, is that studies have found that researchers are spending more time developing software than in the past. So there was a 2018 survey by a colleague of mine, Gustavo Pinto et al., and they found that 8 out of 10 researchers reported spending more time or much more time developing software than they did 10 years ago. And that's a replication study of another study that was 10 years before that, which said the same thing. And these days, because software is seen as so instrumental to the practice of science, and researchers across the board are having to create and use that software in their work, and now really more so than ever. And second, we know that scientific software projects are increasingly collaborative, multidisciplinary, and multi-institutional. Now, while historically, most scientific software, if we go back, has really been the product of individuals and small teams working in isolation to create scripts, to meet their own immediate research needs, major funding agencies like the US DOE have recognized that the present and future needs of scientific computing really do require solutions that bring together many different codes, many different disciplines, and many different institutions. And finally, and as software takes on a more central role in the scientific enterprise, the demand for that software and the consequences of that software are greater than ever. We are being called upon to deliver scalable, high-quality simulations and data-driven analyses to solve the world's challenges. Scientific software today is seen as having all these tremendous economic, social, and political factors of importance. So this confluence of trends is what spurred interest in methodologies and in processes that might enable scientific software developers to become more productive and to work together more effectively. We know that informal and ad hoc software development practices simply cannot keep pace with the scope, the scale, and the complexity of modern scientific software development. Now, at the same time, when we say this, the reality is that scientific software teams have limited time and resources to meet their objectives. So adopting a new tool, a new technique, a new process, this can be disruptive. It carries upfront costs. There's a risk that you won't get any return on your investment, and that wasted time could have been better spent grinding towards the next milestone. So as a result, we as professionals may rationally choose to do things inefficiently, quote unquote, because we can't spare the overhead. And this can be about testing or documentation or issue tracking, you name it. But at the same time, we also know we incur opportunity costs. We end up having to work a lot harder just to keep pace. And meanwhile, when we talk about software process improvement, what comes to most people's minds when we mention this are things that are heavyweight, that are highly prescriptive, that weren't developed with scientific software in mind. We know that scientific software development is different from conventional software development in many significant ways. And a lot of the existing software engineering literature and practice, these things aren't guaranteed to fit the needs of scientific teams. In fact, our conventional tactics, when naively applied, could even be misleading or harmful. So as a consequence, in our work, what we found is that any productivity or sustainability improvements must be 1, incremental, 2, integrated into the primary feature development process. It needs to be a native part of what people are doing. 3, lightweight, and 4, it should be iterative in a way that allows people to revisit their work over time and say, are we moving in the right direction? So that's what led us to PSIP. So PSIP, which stands for Productivity and Sustainability Improvement Planning, is a lightweight workflow that is a set of practices for software process improvement. It is set up so it can either be used on its own, or it can be used alongside other methodologies that you may be using, like Kanban or your flavor of Agile. PSIP is implemented through progress tracking cards, which we're going to describe and delve into in the second half of our tutorial. But at a high level, the goal of PSIP is to help teams figure out where they could make incremental improvements and how they develop their software, and then to help them realize those improvements. So in terms of who's using PSIP, I can give a couple examples for those of you who haven't heard of us. There's a couple teams we work with. Worked with the HDF5 group to make improvements to their documentation and to transition to GitHub. We did a PSIP tutorial with the Technical University of Darmstadt, investigating how this could be used in academic context. We've worked with other teams like Alpine ZPF, teams at Oak Ridge National Laboratory, and our own at Sandia National Laboratories. So what PSIP is overall is it's an iterative, incremental, repeatable, and cyclic process for improvement planning. Software teams may work through these steps on their own or with the assistance of a PSIP facilitator. And what I want to do now is briefly walk you through the steps that are involved in this. I'll drill down here. So the first phase of the workflow is reflection. The teams that we work with are comprised of world-class scientists and engineers, and they're very adept at devising solutions to technical problems. Now, the challenging part is often in identifying what truly matters to them, and then how are those software goals aligned with what matters. So when our team facilitates a PSIP effort, we always start with a team meeting to try and summarize their current project practices using some tools that we'll be showing you here soon. So like, how do they deliver value to their users? What drives the evolution of their software? How do they manage that evolution? And are the tools, the techniques, and the practices they use currently sufficient? Now, this is something teams can do on their own as well, and we do provide resources for this. So once we understand where a team's at, the second phase of the workflow is scoping. We want to figure out where there are barriers to quality and efficiency. That is, what inhibits you from doing what matters. So in setting goals, we encourage teams to hone in on 1 or 2 areas where they could improve in the near term, maybe a week, a month, a quarter, right? And that's when they construct a progress tracking card. Teams can either write one of those up from scratch, or more commonly, what they'll do is they'll consult a catalog of progress tracking cards that we have online, and they use that to tailor one to their objectives. Once they've done that, the third phase is planning, or as we like to say, securing a commitment to action. So where is the team at right now with their goal? What concrete steps could they be taking in a set amount of time to try and reach that goal? What can they realistically commit to doing? Here, this is where we want to see specifics. And then finally, the final phase is enacting the changes. So teams will iterate on their plan and then periodically revisit the PTC to assess their progress. And if there are unexpected setbacks or windfalls, then the team address their strategy as needed. So what we're going to do next is we're going to be looking at a tool here that we'll show you, and you'll get to use, called Rate Your Project. So in the past, when we worked with teams as facilitators, this was a very labor-intensive practice for both the teams and their facilitators. We'd have to sit down with them and really get into the nuts and bolts of how their project worked and what they were doing and what they were not doing and what they were doing well, what they could be doing better. And what we really needed was a guided self-assessment that would enable the examination of all of those things, of their software development, how they plan, how they deal with performance of their software, the reliability of it, and then their collaboration practices. So our activity, and we'll put a link in the chat here for everyone, is that for those of you who want to participate in today's tutorial, we have a site here called Rate Your Project. You go step by step, and we'll show it to you. And it helps you to figure out where you're at with different practices. Now, there are no right or wrong answers, but it would be good for you to pick a pick a project that you have in mind, maybe one that you're working on or one that you're a part of, right? Where you can fill out an assessment for that project, and then we'll use that to drive a discussion. So let me stop sharing here. Any questions so far?
We don't have any questions in the chat yet, Reed.
Great. So we'll get everyone started on this. On our site, what you can do is, load this, there's an assessment. You click assessment here on the left. You say, click here to start assessing your practices, assess your individual practices. And this will ask you just a series of questions about some practices that we often find ourselves working with when we work with teams. So occasion would be version control, and there's a Likert scale here. Oh, is it not? It's not visible? Oh, wow.
No, it's not sharing. Thanks.
It didn't share. I am sorry. Can you see now?
Yes, we can. Thank you.
Great. So what happens is you go to rateyourproject.org, you go to home, and there's an assessment option here. You say, click here to start assessing your practices. You say, click here to assess your individual practices for your project. And then there's a series of questions here just about different practices that your team may do, or different things that are good to do. And we try to rank in terms of overall maturity of those practices. Now, there are no right or wrong answers. It's entirely up to you as to what really this means. But there's a none, basic, intermediate, and advanced. So in the case of version control, none is, you're not using version control. Advanced is where you have a documented workflow for merging your code, you have quality assurance, and then there's basic and intermediate in between. So what we'll do is we'll give everyone about 10 minutes to fill out, those that want to participate, this survey. And then we'll check to see that when everyone's done.
What project should they use for filling out this survey, Reed?
That's an excellent question. So it could be any project that you want to discuss today. So what we're going to do is we're going to use this to kind of explore how to use PSIP and progress tracking cards to help address software process improvement needs. So if you think of a project that you're working on, where you would want to see improvements made, where you would want to secure buy-in with a team and say, we should do this, this is how we're going to do it, that would be a good one to pick.
And as you're going along, if you have questions, please feel free to put them in the chat or unmute yourself and ask them, everybody. So a question in the chat, Reed, should it be a specific task we are working on or a model we are working on?
Well, like it can really be either, but in the context of in the overall context of the project in which that task or model exists, really.
Okay.
If that makes sense, but if you have any additional questions. We have a question here, I believe. Yes. So when you for CJ here, when you answer one of the questions, at the bottom there's a button. There's left and right arrows. You click the right arrow to go to the next question.
I don't have arrows.
Really?
I have 5 things: revision control, code reviews, issue tracking, deployment, documentation, and then there's 4 options for each.
All right. Yep.
I don't have a kind of a help or a tool tips for each of those 4.
Gotcha. So there's a button here. If you want to, is he able to share his screen? I can show you. I can show you mine. One, 2. So from here, from home, go to assessment.
Yeah.
Go to click here to start assessing your practices.
Yeah.
There's these. And
Yeah, there, I'm on this page.
And then click here to assess your individual practices in each area, basically.
Okay, thanks. Sorry, I missed that part.
You're fine. Click, select, pick one, whichever one seems most appropriate to you. No right or wrong answers.
Clever idea that we could try. If you are done, go ahead and raise your hand using the Zoom feature so we can know how many people are still working.
Yeah.
So we have a really nice comment from Maddie in the chat. I'm wondering, Maddie, if you'd like to unmute to just talk about this a little bit. So your comment in the chat is with regard to the text options for basic and intermediate. Would you like to say something about that?
Yeah, sure. I was filling it out and it looks like basic says consistent onboarding process is followed and intermediate's minimally documented onboarding process. So I think they just need to be swapped.
Okay, that's a really good suggestion. And in some sense, this is part of the process of when the team comes together. These are things that you can talk about. So for some teams, it's possible that they have a consistent way that they're working, but yet they haven't documented it yet. And so you could share your thoughts on, hey, I think intermediate is actually sharing a process that we've already documented, or you know what I mean? So I think this is really great that you're really thinking ahead about ways that you can really personalize and modify this this process of sharing surveys. So thanks for your comment. Really appreciate that. And then Chris, you also have okay, Reed's already answered your question. Super.
When you get to the last one, you'll be able to click show me my assessment, and that will just give you an overview. Yeah. We'll give folks here a few more minutes.
Christina, I don't believe the save report feature works yet. It's something that we are working on.
Mm-hmm. Thank you for
Yes, I
letting
will
me know.
note that this website is being actively developed and updated, so not all features are active yet. The assessment obviously portion is active, but there's some stuff we're doing on the back end and the front end to try to make it a little more automated and seamless.
And to give a little bit of context for how this is used, when we facilitate, when we work with teams, what we'll do is we'll have each person fill out rate your project separately and on the same team, and then we compare notes because people have a very different experience, very different experiences when it comes to the maturity of tools and practices and so on. So it usually makes for a very interesting discussion.
So you actually bring up a pretty interesting point, Reed, which is that if anyone in the tutorial would like to learn a little bit more about how to use some of these tools with your teams, that would be something that you could contact us about, and we could talk with you about how to actually facilitate sessions like this.
Definitely.
Jamie, I want to say that very ironically, we had this exact conversation, Reed and Elaine and I in our department meeting yesterday about how to improve hybrid meetings. So this is very fresh on our mind.
Yes, we have ideas.
So Eric has a comment in the chat about having his team do the assessment to see how they compare. And Eric, what we're going to do is in the next breakout session, we're going to try to put the breakout rooms together based on topics, so you can simulate what it might be like to discuss with your team. And that's what I was talking about, is that if in that process you like the way the breakout's gone and you see the interactions, then that's something that we can follow up with in the large group discussion to kind of debrief how that works. And so these tools are available for each of you to use. So you are welcome to use this Rate Your Project link with your teams currently. And we can probably take any information, or if you want to reach out to us if you're interested in the next iteration of the tool, we'd be happy to share that with you.
Right. Does anyone else need more time, or are we good to go? Want to make sure to give everyone ample time.
So please raise your hand if you're finished.
Great.
CJ, do you need more time?
No, I can't find the raise my hand button.
Oh, okay. All right. So you're good. All right. That's what I thought. Something like that. No problem. How about Dr. Murali? Are you ready? If you can't find your raise hand button and you want to just like unmute and say ready, that would be great, because right now it looks like we have half the people who are ready and half of them aren't. Okay.
Thank you, Mark.
Thank you. So Reed,
All right.
I was thinking that for the breakout session, what if we what if people can type in the chat what topic you used or what topic you would like to discuss in the next session. So you went ahead and you went through the Rate Your Project. You've come up with, some areas that you think you might need improvement on. Maybe just like put those topics that you'd like to discuss in the chat so that we can learn, so we know which breakout rooms to design.
Yeah. Otherwise, yeah. And if someone doesn't know, you can always join one randomly. But yeah, if you want to put in the chat, if there's anything that stood out to you in any of these questions, like where something was either the worst, or you say, that's interesting, I wonder if we could do something differently in this or that area.
Okay, so we have a vote for planning. Any other topics of interest?
If people don't have one that they're 100% sure about, we can make one breakout room for each topic and then people can join or maybe hop between them if you'd like. That's okay too.
Mhm. Well, one facilitator for each.
So we have 3 facilitators. We have 1 vote for planning.
Mhm.
So we need 2 more topics.
Yeah. We can also discuss things that are outside of that. So if it turns out that there's, a lot of diversity in what people want to talk about, that's fine too.
Collaboration. Okay.
Collaboration.
How about command decision, planning, collaboration, and other?
Oh, code review. I love me some code review.
There you go.
Yeah, so practices, implementation practices. Development practices.
Okay.
All right. So
Are we
Okay.
ready for breakout rooms now?
I believe we are. So how about this? So anyone's free to join any room they like, but we can try to group by topic for those that are particularly interested. So planning and collaboration would be one, development practices would be another, and the third, yeah. Oh yeah, how about that? Planning, collaboration, development practices.
Yeah. So I'll take
Great.
collaboration.
I'll take planning.
Miranda, you have development practice.
Yes.
Should I be naming the breakout rooms this name?
Sure.
Yes,
That would be
please.
Okay.
great.
Just
Great.
to remind you, you have to be explicit with these directions with me.
Yes, absolutely.
Thank you very much.
And so, Reed, do we still have 25 minutes in the breakout room to discuss?
I think so, yes, because I think we can conclude in the last 5 if each of us reports back up what was discussed in the last 5 minutes for the break.
Okay. So then we will hit the break for the conference at the top of the hour.
That's correct.
All right, the breakout rooms have been opened all, so please feel free to join the room for which you would like to have a discussion.
Yeah, do we have, so we have an other, but there's 3 of us. Do we want to just say, we only need 3 rooms here. If there's an other that doesn't quite fit, you're free to join any of those 3 and we can discuss it as well. How's that sound?
Sure.
So we can close the other room.
Well,
I will
Yes.
have to close the breakout rooms in order
That's
to
fine.
delete that.
You're fine.
Okay. We have to wait for 60 seconds now.
All right. Sounds good.
How do we join a room?
Here in
The
just a
rooms
second.
aren't open just yet.
Oh, it hasn't happened yet. Okay,
It'll
sorry.
be open momentarily.
We have to change the programming.
Yes. Any second now. Thank you for your patience.
Sorry, I have to rename them again.
Oh, you're fine.
Okay, the breakout rooms are now open.
Great. I'll see everyone there. And if one doesn't quite fit, feel free to join any of the three. Great. Now we got everyone joining back in here. So Miranda, would you like to summarize what your breakout room discussed?
Absolutely. So reminder that our breakout room was the development practices breakout room. We had one big general theme in that room, which was code reviews. How do you do them? How do you get people to adhere to them? How do you even get them started? That was really the big consensus question. And for those who already have them, but maybe they exist in a project that's within a larger organization, how do you kind of expand that to that larger organization of teams?
Right. Great. And Elaine, what did y'all's group discuss?
Well, we just got back.
Mhm.
So go ahead, Jamie.
So we were talking mainly about the hybrid meetings and improving those. So a couple of highlights from our discussion was trying to encourage everyone to use your cameras a little bit more in those meetings, and alongside that, Elaine said that one of the ideas would be, even though we have a hybrid team, so we've got 5 to 6 people on site and then 3 people that are fully remote. So when we would go back last year, there would be, several people in a room, with bad camera and bad audio, and then you've got 3 people up on a large screen remotely. But in those meetings, it might be a better practice to just have everyone join individually from Zoom, even though we're in the office together. That may take a little bit of effort on our part, because we may be even sharing an office. So doing a everyone on Zoom at the same time, sharing an office, a couple of us may have to work on that. But in those meetings, when we've got a shared agenda or something we're talking about, I thought this was a really great idea that she had. So if you're looking at something and you're leading a discussion, explicitly saying, it's like, over here on the right on point number 3, let's regroup after 25 minutes to recap. Somebody may be only audio only, they may not be looking at the slides. And you say, oh, and on the second point here on 2B, what practices would you like to focus on improving? Let's explicitly say where this thing is on the shared experience, and be able to, include someone that may not be looking at what you're looking at. So good points all around, I believe.
Good. And then for our group here, we had a number of topics that came up, including adopting better collaboration tools. We had a long discussion on requirements analysis. There are a lot of teams that just don't do them, or don't do them well, don't like intentionally do requirements work. And that comes back to bite them in the butt. Then we talked about software design, or in other ways, how do we manage technical debt, right? How do we design things in ways that allow us to continue to evolve our software? And then a final discussion here was, how do we manage software evolution, right? How do we build in refactoring activities and other stuff to help manage that? So just to summarize what we just discussed in the first half of our tutorial, well, any productivity or sustainability improvements really do need to be incremental. They need to be integrated into the primary feature development process. They got to be lightweight. They got to be iterative. That's our experience with scientific software teams. And productivity and sustainability improvement planning, PSIP, it's a toolkit for software process improvement. Now it's implemented using progress tracking cards, and that's what we're going to devote the second half of our tutorial to here after this 20-minute break, is to look at putting together what progress tracking cards are, and we'll spend some time in breakouts creating them, and then we'll recap and share experiences on how that went. All right, thank you everyone for your participation so far. Hopefully this has been good discussion.
Thank you, guys. Yeah, so we'll go ahead and take a 20-minute break, and we'll reconvene with part 2. So run and get a cup of coffee, just get off your feet and away from the screen for a few minutes, and we'll see you for part 2 in 20.
All right. Screen. We're just now returning from the break. Great. All right. Well, I guess we'll go ahead and get started then. Share. Everyone can see? All right. Well, great. Well, welcome back, everyone. We just got done with our break. And now what we're going to do is I'm going to go walk through and give an overview of what progress tracking cards are, how they are used, how to create them with a team. And then we'll have a breakout session where we'll work through creating progress tracking cards together. And then once again, we'll have a debrief after that and some discussion at the end. And then we'll conclude with our tutorial. All right, so what are progress tracking cards? I said that progress tracking cards really are the core of PSIP, and that's what we're going to talk about here. So at the core of PSIP is what we call a simple progress tracking card, or PTC. So PTCs are concise visual aids that help record your intended goals, your deliverables, and milestones. You create a PTC so you can progressively compare your team's progress towards some intended goal. Now, PTCs will help keep track of your progress towards that objective, and you can share them with others when communicating, say, to other teams about your goals and how you know when you'll have met your objectives. And PTCs are made up of 5 components. First is a title, so a short name that covers the topic of your card. A target, which is a brief description of the goal that you're trying to reach. A story, so that's one or more user stories that frame the goal and provide context. These are often written as a blank, I want blank, so that blank. The card, the core of it, is a numbered series of descriptions of outcomes or states of practice. These numbers usually range from 0 to 5, with 0 representing a starting state where the goal is not met, and 5 represents fully achieving the overall goal. And each successive entry reflects an intermediate state of practice that moves the team closer to that final goal. And then finally, we have comments. So these are details and related links that may be relevant to the card for others to consult. Now, it's all simple enough, but the magic of this process is in how you arrive at them and how you use them. So let's see. When we do this exercise with teams as facilitators, they usually get about this far before they stumble. So they say, we want X, and they'll create a user story like, as a developer, I want X so that our project has higher values of X related quality. They'll put it's 0. We are here. They'll put a final one, this is where we want to be. And then they say, we have absolutely no idea what goes right here, right? And there's a couple reasons why that tends to happen, where things to look out for. First, it's not always clear whether the team actually ever reached a consensus about the goal. The whole team really does have to own an improvement activity, because it's very easy to roll out a new tool or a new method, but they are guaranteed to fall into disuse if only a few are really on board. And this includes all the includes new people, for example. You're not part of the team, you're much a part as anyone else, but sometimes people pick X because that's what the team lead is pushing for. They pick X because they really wanted Y, but didn't want to rock the boat. So having that dialogue early on about what it is we're creating this PTC for, it can be very important. Second, the improvement activity really needs to align with the values and the priorities of the team. For example, we've worked with teams before that say wanted to adopt a continuous integration solution, right? And it wasn't important to them simply because they wanted to make their code more stable, but because rapid feedback on code changes ultimately would reduce their time to science. And that was the real goal. And there has to be buy-in on that why. Now, third, and this is the most common issue we see teams that we'll run into, is that they have an idea about what they want to achieve, but they haven't yet done the articulation work. So articulation work here means the effort required to define what, who, when, and how a unit of work is going to be carried out, right? They say we want continuous integration, and they know they want to hook up their tests with a CI system, right? But do they have tests in place that are suitable for CI testing? Do they have guidelines on how to write those tests? Moreover, the term continuous integration doesn't just refer to a set of technologies, but to a way of working, of getting that rapid turnaround on small increments of change. So the question is, do they have a plan for how they're going to use this new technology? And that's really what we try to capture here in the PTC. So what makes for a good process improvement goal that you can express with the PTC? One, it should be collaborative and team-oriented. So the whole team has to own it. And then two, it should be measurable and it should be specific. Adopting and improving your software processes really should be tied to some tangible evidence, like specific artifacts, outcomes, practices, or policies that are put in place. And then finally, a PTC should be realistic and it should be able to be realized in increments. Now, larger goals are fine, right? If they can be factored into smaller increments with delivered value. So for example, if your team wants to, let's say, have a goal of comprehensive testing, you'll want to specify incremental goals in making your plan towards that comprehensive testing objective. So just to give an example, I'll give an example here, and we'll go through some real world examples we've done with teams, in the wild. Let's say we want to make a card for continuous integration. The target here is that testing is run at appropriate times without human involvement. The reports that you generate should be direct, they should be concise, usable. And a user story for this might be, as a person responsible for software quality and correctness on my project, I would want code regularly tested so that regressions are guarded against, and then new code is tested against itself and other commits that the developer might not have handled before. So everything that's going in is tested, everything that was previously there should also be tested. So one way we can go with this, with making a card, is to start that as a starting point, as a baseline, say we need to have regression and unit tests, but maybe these are only run when requested by a developer. There's no CI system, but we do have to have those tests in place before we can talk about CI, right? And then maybe the end goal here is new code coming in can't be integrated if automated tests are not passing, right? So if the end goal is to guard against regressions, we can define it that way. And then from that, we can derive other things, like, for example, that the tests are run according to team policy, right? Run automatically. Then the test reports are generated as needed. They're archived so that people can get back to them and review, okay, so why did this change happen? Why did this test pass or fail, right? And then ultimately, code may not be integrated, and automated tests fail. And you might even add a bonus objective here, that a mechanism and a policy exists to integrate code without having passing tests in rare circumstances. So you have policies for getting around the system if it does prove problematic, right? But notice that in trying to describe this card, we didn't discuss the adoption of specific CI technologies. We didn't outline specific dates for having things done. Rather, we had a sequence of states of practice around continuous integration to ensure successful adoption. So the goal here is that every time we're moving up on this card, right, from one state of practice to another, that the team is better off than before, even if they were just to stop right there. If they were to stop with test reports are being generated and archived, but maybe they're not yet integrated. They're not like keeping code from being integrated, right? But they're still farther along than when they started, which was they didn't have any automated testing infrastructure in place at all. So when you have that, and you have that card, then you're able to define tasks, right? And that's the point at which you can come up with, actual concrete tasks, like we need to organize our tests for the CI suite. We need to figure out okay, what CI solution do we want to use? Are we using GitHub Actions? Or are we trying to use Travis CI, right? And working through those. And now at this point, before I go any further into some specific concrete examples, I want to stop and ask for questions, like if any of this is unclear so far. Anything in the chat?
Don't worry, I am monitoring the chat, Reed,
Okay.
and there hasn't been anything so far.
Well, all right, sounds good. Well, feel free to interrupt me at any point, right? And we'll walk you through this in the breakouts on how to put these together. So I want to give you an example with the when we did some work with the HDF group. So the HDF group is a nonprofit organization. It has the mission of advancing state-of-the-art open source data management technologies, and they're the developer of HDF5, which you may be familiar with, which is that high-performance software and data library format. Right, it's been adopted across multiple industries, and we had the PSIP and Ideas had a contract with them through LNL to study the effectiveness of PSIP and helping them bring about software process improvements. THD identified 3 areas of improvement that they really wanted to work on. They said, we want to adopt a workflow for keeping our documentation up to date. We want to have a game plan for migrating to GitHub, and we want to adopt code standards. And good news is that progress was made on all of these fronts. In particular, coding standards were agreed upon, and that was something that the team had not yet achieved in over 20 years, right? They had yet to reach a consensus on what they wanted for coding standards, right? And that was something that they were able to do with PSIP and with PTCs. So to give a real world example about how that works, so they put together a progress tracking card for their coding standards. The ultimate target, of course, is to eventually convert the code base over to some agreed upon standard. And in putting together user stories for this, what they realized is that people are wanting coding standards for different reasons. And that's something that came out of their dialogue. So on one hand, as someone that's a library maintainer, they want guidance on selecting and implementing coding standards so that the code is as easy as possible for everyone to read and understand. On the other hand, for all these different community contributors and other library developers, they said that they wanted support so that they could comply with those standards with minimal additional effort or ambiguity. And that implied that they needed to automate. They wanted to have standards that they could automatically enforce to the greatest extent possible. So what ended up happening is they started off with no coding standard. That's where they're at. And then they said, we want to get to a point where tool support is in place that can help ensure compliance, and that running the tool is just part of our standard contribution process, just how we do our, our code work. So from that, and they worked inwards, and they said, okay, we have to agree upon a standard first, right, that everyone's happy with. Then we need to make sure that new code coming in complies with that standard. Now, old code may or may not, right? May or may not make it in immediately, right? And this gives us an opportunity to conduct a feedback session. So we could say, is this standard going to work for us after we try applying it just on the new code, right? And then they say, we're going to put a refactoring plan in place to bring that older code, the pre-existing code, into compliance with that standard. And for the first task there, so what they did was they wanted to identify a coding standard. So they went out, they reviewed the different standards that are out there. They presented their findings to the HDF5 development community, and they worked together to select a coding standard. And ultimately, they published a best practices document, a coding style document, and other resources, right? So as for how to get started with PTCs yourself as a team, what ends up happening is, as a team, you work together using like Rate Your Project or other tools, right, to identify practices that you want to improve. And then second, you construct the PTC. Now, we'll show you that we have a catalog online that you can select cards from, but you can also work with, a facilitator or on your own to build one from scratch. And then the idea here is that you want to adapt the card for the team. You fill in any specifics that you feel that you need to, and then you integrate that card into your team's work tracking system. So we've had some teams use actual paper cards. We've had others do it as issues on GitHub or stories or epics on Jira. There's many different ways in which you can integrate these PTCs. So once it's constructed, the idea is that this should be referenced frequently. So I have a team that I worked with where I was in on their weekly stand-ups, and every week my job as a facilitator was just ask, okay, how are things with that card, right? Are there any roadblocks, anything that's unexpected, right? Or to nominate someone whose job it is just to check that, right? And you continuously assess progress. So with that, if there are any questions, I'd be happy to take them. But otherwise, we're going to transition over to the breakout.
And for this one, Brett, the breakouts will be the same rooms as before. So we'll have those same 3 rooms. There was only one person in the collaboration room before. So if that one ends up not having very many people, Elaine, feel free to just hop into a different one. But Brett, 3 rooms, same as before.
Okay,
Thank you.
they should be open now.
All right, everyone. So the 3 rooms as before. There's the development practices, there's the collaboration, and there is the planning room. So join the room that you're most interested in, and we're going to work on this activity for project tracking cards together.
Great. Welcome back, everyone. All right. So Miranda, would you like to cover what y'all discussed in your breakout room?
Sure. So we spent the first about 15 minutes making a progress tracking card together. The topic that we chose was the release management process. So in this mock scenario we came up with, the software package that we had didn't have a documented release process, wasn't necessarily released regularly. I will happily share our card.
Yeah, please.
Because we did, in fact, make one. Give me just 1 second to bring it up. And so at the end, we ended up making this card. So release management process, our target was that we wanted to have an automated release management process, something that, reduced some maintenance and took some people out of the equation, that was well documented and adhered to. Your user story, and we had an interesting experience of not everybody in our group knew user stories or had used them before. So we got to also have like a little quick tutorial about user stories. But so we went through and we talked about what these might look like, how we might break apart these stages. And for us, we decided, if we're starting in this category of having no documented release process, we don't have this well defined at all right now. First stage would be probably defining what does a release even look like for this. The second one, where we talked about having a schedule for it, and Elaine popped in and gave us another phrasing for how we might phrase that. So a schedule for releases has been created and communicated. Third step would be actually determining some tools that we might use or some steps for actually getting to an automated process. And then the last stage was getting to that well-documented and adhered to process, which is hopefully mostly automated. Ideal scenario may not be entirely automated. There might still need to be a person involved, but
Great.
And then from there, I released the other participants into the wild to work on their own. Chris ended up doing one that was very similar about a data management or a data release process. And that's what he was interested in. And that's what we had time to talk about before the breakout ended. But if there's anybody else from my group who would like to kind of mention anything about it, I welcome you to do so now.
Do we have time to have folks share their cards if they created different cards? Because your approach was a little different from Reed's group.
Yeah. Yeah, I can do that. I can share the one we worked on our team. Yeah.
Any takers from Miranda's group before you do that?
Of course.
Chris, would you be willing to share your card?
Well, it's an email to myself. I didn't have a blank card to start with, so I just was
you're fine.
Formatting it in. Do you want me to share?
No
the
pressure,
screen?
Chris. You don't have to.
Or
but
you can tell
if
us
you
about
want
it.
to.
Yeah.
It looks similar to the card that Miranda had for the software release, but it was because in our group we've been talking about how do we get the final data release from the aircraft out, after a field campaign, and how do we be able to reproduce it 10 years later? And we just talked about how I got burned. I tried to do one from 15 years ago, check the code out, but that was 32-bit computers back then, and I'm trying to compile it on a 64-bit machine today. So the group has talked about, should we do it in a Docker container, stuff like that.
Nice.
Thanks, Chris. All right, Reed, go ahead.
All right, sounds good. So what we focused on in ours was on requirements engineering. And so here's what we ended up coming up with. So what we did is we said, well, what do we want to work on here? And that is, we want to improve the development team's efficiency by identifying what's actually important to be working on, right? So we're doing what's really needed, not doing things that are unneeded, and making sure we don't miss anything really important, right? So having some kind of process for requirements gathering. And we came up with a number of user stories from several different perspectives, right? So from the developer's perspective, you want to know what the requirements are. So you build the right things. But from a user perspective, you want a requirements process that's transparent. You want to know that you're communicating clearly to a development team on whom you rely, that we all understand what we're building and that we have a shared mental model for it, right? And then as a project leader, it's about priorities and making sure that everyone is prioritizing the right work at the right time so that we're able to deliver value. So we took that and then we broke that down and said, from a starting point, the team may do ad hoc requirements gathering, right? But maybe they don't have anything organized with it. They don't do anything consistently. They don't store it anywhere, right? It's really informal, right? And then what we said for 4 was the team has a shared process in place for gathering and reviewing requirements. And then we thought about how to get to that, right? So we said, as a starting point, you could have agreed upon requirements gathering techniques and say, if we do interviews, which we should do, we should take that and we should store that data somewhere so that we can look back at it and make sure we understood the customer correctly, right? Then having a format for recording those requirements, then having a definition of done, saying we're going to agree to do these things. Every time we say we got work done, we're going to have our CI testing in place, test it to pass. We have code review. We take it up with the customer, make sure they're happy, right? So that's your definition of done. And that's how you get to that shared process through all of that. And once you had all that, we actually added on a bonus if there's time to get to it, which would be, now that we're gathering requirements, we can now do regular reviews of our backlog and say, okay, so what do we prioritize in the future? What should come next, right? And then periodic retrospectives. Okay, so what went well this time? What could we do better? And so you see here, what the important thing is that in all of this, we didn't say anything about particular requirements gathering techniques. We didn't say anything about particular requirements formats or methodologies, right? It's more about, at each stage, the team is better off than they were before because they're doing something new or something different in a way that gets them towards that ultimate goal, right? So that's what we came up with.
What I also like about this card is, as a project, I would say as a project leader, for example, I can see the deliverable at each of these levels, or I can see the result. So it's like very results. It articulates the result, but not necessarily how you got there. And so the how you get there are the task lists. But this card communicates that these, we'll know we've arrived at stage 2 or score 2 when we know we have completed XYZ. Mm-hmm. And so this allows the team to have some sort of, I want to use measurement, but not in a very, don't take it in a bad way. It's a way for a team to kind of assess themselves as to whether or not they are at the level that they would like to be. And so, of course, these words can be played with a little bit too and modified as the team goes through the process. Those were really great cards that you guys came up with.
Yeah, it's great.
Both your breakouts.
Yeah, these will make for excellent additions to our catalog. Great. So what I want to do now is I will kind of summarize what we've discussed here today. And then if there are any final questions, comments, or discussion, we can have that. All right, so let me take that. A little debrief. So overall, say you want to adopt PSIP as a toolkit, you want to use progress tracking cards, you want to get your team on board with doing so. Best arguments that we can make for why PSIP, right, would be one, that it's lightweight, this is not very heavyweight, it's not prescriptive, that makes it easy to adopt, we believe that doing things like going through your project, having that discussion, working through creating progress tracking cards, it encourages reflection and communication. It can reveal differences in different team members' assumptions and priorities, and that you can have that dialogue. And then ultimately, it helps teams converge on a consensus on what's important and why we're doing things, right? Not just that we're going to, adopt this new tool, but that we're going to make it part of our workflow, right? That we're going to commit to doing X, Y, Z, right? There are things that you need the team buy-in on, and that's what PSIP helps to do, is to achieve that consensus. So as a conclusion, the focus of this tutorial has been on a method for software process improvement that the IDEAS team has developed. That is PSIP, productivity and sustainability improvement planning. It's a technique for realizing process improvements without disrupting current development and for mitigating technical risk so that you can develop your software with confidence. And by now you should understand what PSIP is, how to identify topics for improvement by rating your project, progress tracking cards and the progress tracking card catalog, and then how to integrate PPCs into your project. And I want to thank everyone for taking the time to attend today. Hopefully this has been an informative session. It was very enjoyable, I'm sure, for all three of us. And if you have any questions for us here at the end, we'd be happy to take them. Or comments.
Well, I
Yeah,
have a question for the group. Okay, go ahead. Yeah,
No,
question.
I was just going to let folks know if they want to either use the chat or just unmute themselves. Feel free to do it either way.
So I've got a question in general for everyone who participated in this process. What parts of it would be something that you could see adopting today, if anything? What was hard or challenging? So if you'd just like to have a general discussion about that, that's something that we would really appreciate. Must be lunchtime for everyone.
I'm getting hungry, that's for sure.
Lunch or afternoon siesta.
Porque no las dos. Well, if you have any follow-up at any point, we put our emails in the chat, that kind of thing. We'd be happy. Feel free to reach out to us, and thank you again, everyone, for joining. It's a very, very entertaining session for us, and I hope it was very informative for you. Thank you. Yes, thank you, Christina.
Thank you, Reed, Miranda, and Elaine. That was a very excellent tutorial. Really appreciate it. So we do have 5 minutes until the next talk. So if you do want to take a brief break, we'll pick back up at 11:20 with a talk from Scott Pearse over at NCAR on visualization software. So see you guys at 11:20. Okay, welcome back to ISS. We have one more talk before the lunch break. So Scott Pearse is going to be talking to us about Vapor for data visualization. Go ahead, Scott, take it away.
All right, thanks. Yeah, my name is Scott Pearse. I'm a software engineer on the Vapor team up at Sizzle. And I have to scale this talk back a little bit because of time constraints. In this talk, I'm just going to be talking about Vapor's user experience and our philosophy that we take when we present the application to our users, and also Vapor's software architecture specifically pertaining to its GUI. If you don't know, Vapor is a desktop software application for scientists to do 3D visualizations of their data. Let's see, slide forward. Vapor is open source and it's cross-platform. So we distribute binary installers for Linux, Red Hat, and Ubuntu specifically. And we also distribute installers for OS X and Windows. And our goal is to make 3D visualization as easy as possible for geophysicists. in this world, we have many options when it comes to 3D visualization applications. There's Vapor, there's Visit, there's ParaView, there's Blender, Maya, Houdini, even Google Earth, and there's even more. So what room is there for yet another 3D visualization application? Well, there's room for Vapor because ease of use is not typically very high with any of these applications. And scientists, at least the ones I've spoken to, shy away from 3D viz because of the complexity of the applications that they try to use. They'd rather focus more on their science than toy around with 1,000 different buttons and fine tune a visualization. So Vapor's goal is to make it as simple and straightforward as possible and not bombard the user with options off the bat. Before I crack Vapor open, our website where you can find downloads, documentation, and video tutorials is vapor.ucar.edu, and you can contact us through email at vapor@ucar.edu or on our online forum at vapor.discourse.group. And so with that being said, I think the best way to show how Vapor works is to open it up and kind of get my hands dirty with it. So I've installed Vapor. I have this V icon at the very bottom. I'm going to click on it to open it up. And we can see here this big kind of empty screen. Everything is disabled and grayed out. We have some shortcuts up top over here and a control panel over here on the left where we will control a renderer. A renderer is basically an algorithm that will color your data according to a color palette in different parameters like opacity. But of course, the first thing we have to do is get data into it. So I'll go to the File menu, click on Import. And one of the ways that we try to cater to geophysicists and make it easy for them is to natively support certain file formats in communities that are close to us, like WRF ARW. We support kind of generic NetCDF, but it has to be CF compliant, which means that it has certain metadata attributes applied to it. We also support impasse, brick of values, which is basically raw binary data that's described by a text file. We support some kinds of particle data and also UGrid data. But for the demo, I'm going to select NetCDF, CF compliant, and go to our canonical demo data set, which is of a F5 tornado. This simulation was done by Lee Orff at the University of Wisconsin-Madison. And I'm going to pick maybe 4 of his files that are interspersed by 1 second time intervals. So now that I've loaded the data, I have this kind of white cube. This is the data domain. All the data exists within these extents. And all of my options have now been enabled. The first thing I have to do is create a new renderer so we can actually draw data according to a certain rendering algorithm. So I'll click on New, and these are the roughly 11 different renderers that Vapor supports. We can do wind barbs, contours, flow, streamlines and path lines, certain maps, ISO surfaces, cross-sectional slices, and I'm going to pick the, I double-click the volume renderer right there. So by double-clicking on this volume renderer, we instantiated a new volume renderer, which colors the entire field of data according to the color and opacity values that we apply to it. So now that we've instantiated it, we have the volume renderer up in this table on the top left, and we can turn the volume renderer on by clicking on this checkbox. The first thing we see is a basic volume rendering of DBZ. We can see what variable we are currently rendering in the variables tab, and currently we've selected DBZ. Now, one of the approaches that we took when designing Vapor 3 was to make all the renderers behave as identically as possible. So this volume renderer has a variables tab, an appearance tab, a geometry tab, and an annotation tab. And all renderers have those tabs. If I, for example, create a new slice renderer, right now my slice renderer is highlighted and I see my slice controls. There's also a variables tab, appearance tab, geometry, and annotation tab. And the idea behind this is that once you learn how to use a volume renderer, then you can go and create any other renderer and roughly know the same way to apply parameters to that renderer based off of just learning one. So you learn one and you should be able to learn them all. All the renderers have these tabs. And the variables tab kind of pertains to what we are rendering, the current variable. The appearance tab is how we are rendering it. In other words, how we are applying color and opacity, in this case to the volume renderer. And the geometry tab is where we are rendering to. You can see I can trim down my Z extent like that. And now I'm only rendering to the lower half of my Z axis in my domain. The appearance tab is kind of the heart though. This is where all the color and opacity values are set. And they're done through this thing called a transfer function right here. The transfer function is basically just a distribution function of the data. This plot right here is just the data values between -36 and 75 for our simulated reflectivity. And this is the distribution, the PDF of those data values. And the colors below these data values are determined by this color bar down here. So basically low values are dark blue transitioning into white, and then deep red for high values. I can constrain the band that this color value is being applied to by changing the extents at the bottom. And I can also add new control points. So if I want things to skew more red like this, I can double click on the control bar and drag these control points like that. So that's how color is applied. Opacity and transparency is done through this black bar up here at the top. We have 1, 2, 3 4 control points right now. I can click on these and drag them down, which will make the data values where this black bar is low on the y-axis of the histogram. These values will be completely transparent, but if I drag it up, they become more and more and more opaque. So if I delete that by double clicking it, I can drag this, and now all these values from the left side all the way up to this data value of approximately 35 are completely transparent. And that's basically how color and opacity are applied to the volume renderer. And the same goes for the slice renderer and all the other renderers. If I disable volume, enable the slice also has an appearance tab where I can do the same thing. To do a capture of an animation sequence, if I turn that off and I turn my volume back on, I can click on the capture menu and capture an image sequence to make an animation. And I'll select PNG files, and I'll call this, I'll just call this X. So all my images will be prefixed with the character X. I'll save it, and then I can animate forwards in time. Okay, time step 1, 2, and I can go to my home directory, and we should be able to see these files, which are my screenshots. Whoops, wrong button. And then I can use something like FFmpeg to take this series of images to make a movie, like the one we saw of, gosh, I think I forgot to mention that animation that we saw at the title screen. That animation was a volume rendering of the East Troublesome fire that happened near Lake Granby earlier this year. But that's basically Vapor's user experience and how we try to make it easy for scientists to pick up and run with. Going back to my slides, and here again, we have the East Troublesome fire, a volume rendering of that created with the same approach that I just demonstrated. So with the UX kind of being covered, I want to talk about our architecture. And like most desktop applications, Vapor is using the design pattern called Model View Controller, where the model is kind of the data model, the internal state of Vapor. The view is what we are viewing. So we just looked at a volume renderer, and that was being rendered on the screen on the right side. That is Vapor's view. The controller is the GUI, so that would be the transfer function and other widgets that we were manipulating to change the color and the opacity of the transfer function. And so the user uses the GUI or the controller, which manipulates the internal data model, which is read by the view or the renderer, and then the user sees that. And so for our model, we have an internal XML file that allows for things like undo and redo, as well as saving the state to files so that a user can create a series of renderers, save the state, close the application, and then come back to it later. That's all done in XML. Our view is 99% done in OpenGL. We also support a CPU-based rendering library called Osprey for unstructured grids. And then our controller is done through a framework called Qt. Qt is a free to use framework as long as you're an open source application. And in Vapor's parlance, we refer to these different components as our params. So our data model we refer to as a params instance. Our view is a renderer instance, and our controllers are called event router instances. And so when we created a volume renderer in that example a second ago, we instantiated an instance of volume params, an instance of a volume renderer, and an instance of a volume event router, all pertaining to the data model, the renderer, and the GUI. So we used to design our GUI in a much different approach, and it's actually the canonical approach that most projects use when designing application GUIs with Qt. So I'm going to show you guys how we used to do things with Qt Creator. And now we have a new way that leaves us less prone to bugs, and it gives us a more consistent user interface. And there's big benefits to the new way we do things. So I'm going to run through how we do things with Qt Creator. And this is the canonical way that projects are usually spun up with Qt. So I'm going to open Qt Creator, which is an IDE that provides kind of a WYSIWYG interface where you can drag and drop different widgets and then program them all in one place through this. It's a pretty powerful IDE, but we're moving away from it, and I'll touch on why in a minute. So for my demo, I will go to File, New Project, and just go with all defaults. This will be Untitled 2. The build system is QMake, and the class that we will be editing will be called main window. We will be defining functions in the header file, implementing them in the CPP file. And then finally, there is this notion of a UI file, which is an XML file that describes the WYSIWYG hodgepodge that we put together. So we're going to drag and drop widgets into a WYSIWYG editor, and that will be written to a UI file. And then my target is a desktop using Qt 5.15.2 using Clang 64-bit compilers. And that's it. Here's my main program. All it's doing is instantiating my main window, showing it, and executing it. So we're not going to really touch anything in main.cpp. Our main focus is going to be on main window.cpp, which is going to hold all of our business logic. Qt Creator is giving us a default constructor and a destructor, and it's also instantiating or initializing this pointer, which is called UI. If I go to my header file, we can see this pointer as a private member. And what this is basically an interface to the WYSIWYG editor that we are going to drag and drop our widgets into. So if you didn't see that last part, these are our files, and when I double click on main window.ui, we get taken to our WYSIWYG editor, where I will grab, I'll grab a horizontal slider. Let's see, a progress bar. And let's give it a label. And I'm going to call this, for example's sake, this will be the, if this was going to be a component in Vapor, we would label it according to the parameter that is changing. So let's call this the volume density example. And in Vapor, if I open it up, let's see, our volume density slider exists in the real world right down here. But for example's sake, we're just giving it a simple label. And I can go ahead and compile this and run it. And this main window should pop up. But one thing that we're going to notice is that these widgets are kind of haphazardly thrown into the GUI. They're not resizing themselves appropriately, and they're not repositioning themselves according to the size of the window. So Qt has this notion of a thing called a layout, which basically lays out your widgets according to a certain policy. So I'm going to right click on my container, my main window widget. I'm going to go to layout and lay it out vertically. And so now these are all laid out in a vertical fashion. And I'm going to reduce the horizontal and the vertical size, save it, and run it. And we should have something that looks a little more reasonable now that we've laid things out. Okay, so we have our slider, we have our progress bar and our label, but nothing's happening. And so in order to make things happen with this one interactive slider that we have, we have to employ a system that Qt offers called a signal and slot connections. Basically, all the widgets in Qt can emit signals upon certain events. So this slider, when I click down on it, it's going to emit a mouse clicked event. When I slide it, it's going to emit a slider changed event. And then when I release, it will emit a slider released event. So it's our job to capture those signals and then apply logic through what are called slots, which are functions that are designed to react to signals according to our requirements. So I'm going to close that, go back to my editor, and go back to main window.cpp, and I'm going to make a signal slot connection. The way that's done, I type in connect, and then the first argument is the emitter of the signal. And so I will access my horizontal slider through my UI pointer. Again, this UI pointer right here lets me access what I've copied and dragged and dropped into my, my WYSIWYG editor. So that slider, now I have to define the signal from that slider. That will be a reference to Q slider value change. And then the receiver or the respondent to this signal, I'm just going to have my progress bar respond to it. So UI progress bar, and then the slot, the reaction to the signal will be a reference to the Q progress bar set value function. So what's going to happen now is whenever the horizontal slider emits a value changed signal, our Q progress bar will then set its value according to this function. So let's see if that runs and compiles. And what we should see now is our, let's see, there it is. Our progress bar is now following our slider due to the signal and slot connection. But this is insufficient for most use cases because we want the GUI to interact with a data model. We want the controller to affect the model. And so what we have to do is write our own custom slot. So for that custom slot, I'll do main window. We'll just call this update. Receive an integer. And I'm not compiling and linking against Vapor, but the way we used to do things was that we would have to retrieve a pointer to one of our model classes. So I mentioned earlier, when we created a volume renderer, we had a volume params class instantiated. We would reference that by doing something like this. We would have a get params function that would return volume params. And then we would act upon the signal that we're receiving by calling some kind of setter, like set volume density, like that. And then additionally, we can also do whatever else we want, like update the progress bar. Set value, is this right? And of course, this is not going to compile because I'm not compiling and linking against Vapor. So these two won't work. But basically what I can do is now, instead of connecting directly to the slider, I can connect to my main Windows function update. And I have to define this slot header file. Let's see if that compiles and runs. Did I not save my header? Well, maybe this isn't worth debugging right now, but the point would be that if this did compile and run, we would just be updating the progress bar through our slot instead of a directly connected native function to the progress bar. We would also be doing things like setting values in our model. database. Now, the problems that come with this strategy are that, number one, every single widget in the application needs its own custom slot that executes the change to the params database. Some might do validation, some might not. Some might do bounds checking or anything the programmer might want. So the fact that every single widget has its own interface to the database means that there's inconsistency introduced through all these custom slots. And you can see if I open Vapor up and I go to like this tab, there's dozens and dozens of these widgets, and writing dozens of functions with custom behavior on our model database. That was leading to a lot of bugs, issues, and inconsistencies. But the inconsistencies don't end there. Additionally, if we go to the UI file, we can see over here on the right, this is a queue slider object, and these are all the properties over here that pertain to it. And what we found is that some engineers might use an expanding horizontal policy. At some places in the application, some might use fixed. And so the appearance and the layout of the GUI was inconsistent because we were just dragging and dropping individual widgets and then custom tailoring them according to however we felt on a given day. So there was inconsistency in the layout, inconsistency in the slots, and there's also inconsistency in the signals. I mentioned earlier that this slider emits signals on mouse clicked, it emits signals when it's dragged, and it emits signals when it's released. And all these widgets emit up to a dozen different signals, and our developers weren't always consistent with which ones we were listening to at which time. So this all brings us into the new way we do things with these classes that we call P widgets and V widgets. And these are intended to standardize the appearance and the layout. So we do that with V widgets. They standardize the layout, the signals that we listen to, the slots that we care about, the setters and the getters. And so everything like on the appearance side of things is handled by our V widgets, and then the P widgets, right, these standardize the controller. The P widgets standardize the GUI's interaction with the params or our data model. So the V widgets standardize the controller, P widgets standardize the interaction with the model. And what this kind of looks like is for every kind of widget or queue widget that is out there, like you can see that here we have a queue checkbox, we make a corresponding V widget, which the inheritance chain here is that it starts with a queue frame, which is a basic layout widget. If you remember in the example, I applied a layout to my main window, and we do that by inheriting from queue frame and adding our custom behavior in a V horizontal box widget, which controls size policies and padding and things like that. We then inherit from the HBox widget with whatever class it is that we want to wrap around a queue widget. So our V checkbox owns a queue checkbox. It listens for only one signal from the queue checkbox, and it only emits one signal, which is value change. So anything that's going to interface with a V checkbox only has guardrails. There's not like 5 different signals to listen to. There's only one, and we have standard setters and getters with common names amongst all V widgets, whether it's a V checkbox, a V slider, etc. And just a quick note on why it's important. These are the signals that are emitted by the queue checkbox. So some engineers might interface to the clicked signal, others might interface to pressed, released, toggled, or state changed. This is what was causing so many bugs and inconsistencies in our previous iteration of Vapor's GUI. On the P widget side of things, basically the P widget base class just gives an interface to acquire a pointer to a parameter class. So we had a volume params class instantiated in the example earlier. The P widget just allows access to the corresponding parameter for the current value being changed for that params instance. So the P checkbox will own a V checkbox. It will listen for that value changed signal. And then based on that, it will take its pointer to the volume params and make the appropriate changes. And the signatures are all pretty simple. All you need in the constructor is a string that we call a tag, which identifies the parameter that we're changing. So for our volume density example, the tag would probably be volume density tag. And then you give it a label. We can see in Vapor, the label is just the text that shows up to the left of the control widget. So volume density would be the label, and then the tag would be the volume density tag. And so looking at this from a big picture perspective, we have a Q checkbox, which is owned by a V checkbox. The V checkbox will listen for signal, specific signal from the Q checkbox, relay that to the P checkbox, which will enact changes on volume params, which will be recognized by the volume renderer in the view and updated. So this strategy has led to fewer bugs via consistency in our emission of signals and the signals that we are listening to that come out of Qt. And it also adds consistent layouts among all widgets. They're all going to look the same no matter where you are in the application. It also makes our interaction with params consistent. And I have to give a big shout out to Stosh. He's my friend and associate on the Vapor team here. The P widgets were all his idea. And the result of it is not only fewer bugs and more consistency, but we also were able to eliminate 10,000 lines of our GUI code. So that's a 23% reduction in code that we now have to maintain. And so that was a pretty big win for us, taking this whole approach and moving away from the canonical way of doing things in Q. And just for an example, this is kind of how you would write code for P widgets. We have a section called barbs, and if I open up Vapor, just to show you guys what, let's see, I'll do a new barb renderer. And this section right here that says barbs, this list of widgets is what we are generating. Like if we see X barbs here, there's an integer slider edit right there. That is generated with this one liner. So you just instantiate a new P integer slider edit, give it the tag, barb or X barb count tag, and then give it a label, X barbs, and then optionally give it a range, and then just one by one down the list, populate your GUI with simple one-liners. It's very powerful. So I think that's it. Am I at the end of my time? I forgot to set my timer.
Yeah, we just have a couple minutes here for questions.
Okay.
If folks can post their questions to Slido, we'll be happy to address those here for a couple minutes. Next up after this, though, we do have a lunch break, and we'll pick back up at 12:50. Again, if you have questions, go ahead and post those to Slido, and we'll get one or two of those in now.
Cool. I don't have Slido open, so let's see. I'm not sure how to access it either.
I'll go ahead and say then, if you want to post your question, Kelvin just messaged me from Multimedia, says we have no questions posted to Slido yet. So when we do have them come in, we'll pull it up on our screen.
Okay.
And we'll get them read out for you.
Thanks, Gail.
So I'll just say thank you, Scott, for the talk today. Really great stuff you have going on there. Since we are at time, we'll go ahead and call for our hour-long break for lunch, and we will pick back up at 12:50. So we'll see you then. Thanks again, Scott.
All right, thank you.
Okay, so that brings us to our next session. We're actually going to have two back-to-back instances of a tutorial. So part one and part two with a break in the middle. I'd like to really welcome and appreciate Dr. Vicar Eijkhout and Dr. Amit Ruhela, who both joined us today from TAC at UT Austin, who are going to talk to us about using advanced features in the latest implementations of MPI. So as I mentioned, the first session is going to run from 1:20 until 2:20. We've got a scheduled 20-minute break, and then we'll pick up with another hour to round out the day. But of course, since it's your time on either side of this, feel free to try to put the break wherever it makes the most sense, and we'll be flexible. I do believe we're also going to be using Slido for this presentation, and maybe even using the poll feature. So with that, thank you very much, and I will let me know if I can be of assistance.
Okay, I should be sharing my desktop at the moment, so you see my slides and peeking under it a terminal window in case I need to show some code. And MPI 3 and 4 has too many topics, so Tasia has just put a poll in Slido, so let me know which topics you would preferably see so that I'll make sure that we get to that. So there is the Fortran bindings, large data, atomic one-sided, advanced collectives, shared memory, graph topologies, partitioned sends, and this sessions model. So please vote for what your favorite is, otherwise I will pick my own sequence. Oh, and so I'll fill up about 3/4 of the 2 hours, and after that my colleague Amit will talk about the new tools interface and the profiling features in MPI 3 and 4. But I have too many topics, so let's see. Okay. So far, shared memory, atomic one-sided, MPI count. Okay. Okay, so shared memory. Shared memory is leverages features of MPI one-sided communication. So for one-sided communication, so that has the most votes. So I'll start with that. Right. These slides don't have a recap of MPI one-sided, but if it's necessary, post a question in Slido and I will explicate a little more. So shared memory is based on features from one-sided. Namely, in one-sided communication, you cannot just access any part of memory of another process. Every process has to declare a so-called window, which is it's a view into its memory area, and that part is visible to other processes. And in MPI 3, no, 2 actually, it was visible to processes only through put and get and accumulate calls. And I see that there is some interest in atomic one-sided, so I will get to that in a second too. Anyway, but the window memory on other processes was only visible through function calls. Now, if you have processes that live on the same shared memory, meaning on a node, then it should be possible, technically speaking, that they access each other's memory. Okay, so that's what happens in MPI 3. Just to get a couple of things out of the way, shared memory. So it's a myth that MPI processes use network calls and OMP threads, and so they're more efficient. Nah. MPI, high quality MPI implementations, if two processes communicate on the same node, it will just do a memory copy. And Tasia, I didn't, can I see that? Thank you. So the shared memory and then atomic. And after that, the large count and sessions. Okay, so I will do that in that order. Thank you very much. Yeah, MPI is not intrinsically less efficient than OpenMP. The main problem with MPI, if you have shared memory, is that each process having its own data space may duplicate certain objects. So it is not possible for multiple MPI processes to have joint access to something in memory. So what is shared memory access? If two processes are on the same shared memory, then they can actually get a double star or something pointer to each other's memory. The limitation is that you can only do that in the context of MPI2, I guess, one-sided communications. Now, you can use this for doing remote updates, but if you start doing stencil stuff with shared memory, you get all the common problems like race conditions and consistency. And so I don't think that is a major argument for shared memory. A good argument for shared memory is, for instance, applications like ray tracing. You have a large read-only data set, and every process then shoots its own rays through that data set, but you have a read-only large data set, and so with shared memory you can store that data set on process 0 and all the other, process 0 on the node, and all the other processes on the node get a direct double star or whatever pointer to it. So that is how MPI shared memory works. Yeah, I more or less said this. So here's a picture of a 4-socket node out of the late Stampede Ranger cluster. So you see the 4 heat sinks. So that's the 4 sockets, and they all have their own DIMMs attached. And up to NUMA effects, any core can access all of this memory on the node. So that is shared memory. Out of your really large cluster, small groups of processes can see the same pool of shared memory. Okay, how does this work? You use a routine MPI COM split type. So there is MPI COM split, which can split a communicator in arbitrary manners. COM split type splits it by a certain type. In this case, the type of being on the same shared memory. Then there is the MPI win. So there are various calls for making MPI windows. There is win create, allocate, allocate shared. And the allocate shared is the one we're using here, where you make a window on a shared memory. And finally, so if you've split your processes in groups that are on the same nodes and you make a window that is on a node, then you can do win shared query and get a direct pointer to the window of another, to the data that is in the window of another process. And now you can use memcopy instead of MPI put. Okay. Oh, by the way, I hope I don't have to, what was the question in the Slack? The chat? Nope, nothing serious. The links to my slides and all that. Oh, this I think the slides are on the conference website, and that also has a link to where you can find my public repository. Okay, so I have an example code, and basically it does this. You can have an MPI info object, or you can pass MPI info null, and you do MPI com split type, where you split MPI com world by the type of being on the same shared memory, and out of it comes the shared communicator. Questions and comments, please, through Slido. And now you can ask, okay, on the shared memory communicator, what is the number of processes, and what is my new process number? And so all of this behaves the way you've always done with subcommunicators. Yeah, the output says there were 8 ranks total, and process 0 says it is process 0 in a shared group, and process 4 is process 0 in a group of shared memory processes. Okay, with me so far? That's com split type. Oh, and so MPI 4, there is another type, MPI com type, hardware guided. So you can split your processes, for instance, by being on the same socket or whatever. So it's implementation dependent. Shared memory question. Shouldn't a good MPI implementation handle shared memory optimizations internally? Oh yes, absolutely. It does that. But so if you do a send between 2 processes on the same shared memory, it will do a copy. There is even 0 copy, but I'm not exactly sure what that's about. So it does a copy, and so that is about as efficient as you can get it. What this does is it gives you an actual pointer to the memory, so you don't have to copy it, and so you get rid of the data duplication. I hope that's enough explanation. Otherwise, Jim, talk to me afterwards and we'll figure out where the problem is. Okay, this is an exercise. We are not going to do that exercise. Oh, this is a really nifty exercise. So yeah, use MPI com split type, and if you run a code, see if you can figure out how many nodes there are and how many processes on the nodes. So for instance, I wrote this program and then I put 10 processes on 3 nodes. And so I figured, okay, that'll be 4, 4, 2. But no, Intel MPI actually nicely puts it on 4, 3, 3. So about as evenly distributed as you can make it. Okay, so com split type. When allocate shared is, yeah, the usual one-sided tediousness. So you specify the size of the window expressed in MPI A-ints. So this many, so you allocate the window as, all right, so there is a window size, and if you are process 0 on the node, then you set the window size to something. So this is a toy example. The window is just one number, and otherwise you set the size to 0. And then you allocate the window as how many doubles, no specific info. You do it on your communicator that was split off. And out of it, you get a pointer to your own data, but you also get the window. Okay, so you've made your communicator that only lives on this node. Now you make a window that only lives on this node. And so every node does this, right? So every node has its own, windows are collective on a communicator. So this window is shared on a node, etc., etc. And now you can say, okay, out of this node window, from process 0, get the size, the unit, and the address. And you're mostly interested in that last item. So you get the address of the window memory on node 0. Okay, here's the prototype of Win shared query. Okay, so this is the basic idea. ComSplit type, Win allocate shared, and then Win shared query. Everyone with me so far? Now there is a couple of subtle issues. So memory will be allocated contiguously. So if every process in this slide, I'm looking at an example where each process creates a window of size 1 double, so that's 8 bytes. And now memory will be allocated contiguously, which is nice because you can actually do arithmetic, address arithmetic over all the windows of all the processes. So this is really cool. You can loop over that whole stuff and do a mem set or whatever. So it's very easy to iterate over all the memories. Now, if you bear in mind that picture of this node, that means that all the windows, because they're allocated contiguously, will wind up on one DIMM, probably the one that core 0 of socket 0 has. But that means that you get NUMA effects for all the other processes. So process 0 has all the memory close to it, but a process that lives on the next socket does not even have its own memory, its own window close. It has to go to the DIMM of the other socket. And so you can actually set a flag, allocate shared non-contiguous in the MPI info object of the MPI win allocate shared. Okay, so I wrote a little code that tested this out, and so I got my function pointers on all the windows. Let's see. Where would I? Oh. Okay, so this is the example program, and it tries both strategies. So I create, let's see, if the strategy is 0, then I set this option. Then I set the option to false, otherwise I set it to true. Oh, that is not visible. I allocate shared the memory with the info object. And now, what do I do? So process 0 gets the address of its own window, and then it asks for all the other windows, okay, where is your address? And it computes the distance as a size t, and it prints it out. Okay, so that's what I'm doing in this code. And now you see that with the default contiguous allocation, the window of process 1 is 8 bytes away from the window on process 0, and process 2 is 16 bytes away. Okay, makes sense? Every window is 8 bytes, and so they are. If windows are non-contiguous, then the distance is 4096 bytes. Does anyone want to post a suggestion in Slido why this is? So it's unlikely that the DIMMs of one socket and the other one are only 4096 bytes away from each other. I'm open to suggestions why this happens. Anyway, so I mentioned the ray tracing as a good example of what you can do with MPI shared memory. The book by Bill Grob mentions chemistry applications, so big shared database as another example of where shared memory could come in handy. And this exercise, okay, that's it so far. Okay, 4096. That is the size of a small page, 4 kilobytes. And so the DIMMs of one socket and of another are very far away in physical addresses, but if you print addresses in your program, you don't get physical addresses, you get logical addresses. And those are partitioned by small pages. Okay, just a little tidbit. Okay. Shared memory. Some people expressed interest in atomic operations. So MPI, I'll have to dig into the history. I think one-sided came in MPI 2. So one-sided operations have been part of MPI for quite a while, but if you try to use them, you get race condition problems. And atomic operations were not added until MPI 3. So if you look at so this is a case study in atomic operations in one-sided. So suppose one process has a table of work descriptors, and every process and a stack pointer of how many there still are, and every process then goes to this table, takes a work descriptor and starts working in, and then decrements or increments, whatever the stack pointer. Okay, so this is a realistic application of something you could do with shared memory. Simplified model, one process has a counter, and then everyone reads the counter, decrements it, and yeah, I want all this to be completely dynamic, so a process will only look at that counter if it is available for doing work. So this is going to be a very asynchronous application. Okay, I assume that everyone knows what a race condition is. Okay, so here is a very simple-minded, this is inside a loop, so you fence, you start your one-sided operation, you get the counter value, and now if my process is available, then let's see, it gets the counter value minus decrement, and then it puts the counter value, and that is the end of your one-sided episode. Note, so every process is reading out the counter value, but only if you are actually available do you do something with it, right? Okay, there's any number of things wrong with this, but I'd like to point out that there is a fence in the middle. That is because a put and a get call don't have immediate effect. If you do a get call, the remote value and the local value are not coherent until after the fence. Likewise, the put call is not doesn't have its final effect until after the concluding fence. Okay, so you need 3 fences. Okay, so the big problem, of course, here is that if in this segment multiple processes are available, they all do a put in the same location on the they put their own the race condition. The remote counter value gets updated incorrectly. So if there's only one available process when you go through this segment, it's actually correct. So what is wrong with this code? So all this getting and putting is only necessary if the process is available for getting work. So why not put that fence inside that conditional? Let's see, are we, okay. Anyone, any idea what's wrong here? So the major problem is with the put calls, which are a race condition. Let me know what you think is wrong with that one. Okay, so what do? We replace the put with accumulate. Okay, that is part of the story, but there is still the problem with the get calls. So if there are multiple processes that are available, they all get the same counter value, and they do the same decrement, and they all get the same work. And so the fact that you're correctly updating is pointless because you get the wrong value. Okay, so what you really want to do is combine the get and the accumulate into one call, and that was not possible with MPI2. Okay, the problem with this code is that the fence is collective, so if only one process is available, this hangs. The problem here, so we need to roll the get and the accumulate into one, and for that there are 2 routines, MPI fetch and op, and MPI get accumulate. Get accumulate is the more general one, and fetch and op is a limited case, but probably the more common case. Okay, so what does the code now look like? Okay, fetch and op is what is the buffer locally? Let's not go over that. All right, here's the annotated call. So the first argument is the data that you operate on the remote value. And then the second argument is where you retrieve the remote data. And now it is done atomically. So, so now we have a fence, the processes that are available, they do their fetch and op atomically, and then it's, so is this code good? No, it's not quite good. Oh, by the way, here are 2 reduction operators that you don't normally use, but so MPI fetch and op uses a reduction operator for the the operation. And you will often find yourself using MPI replace and MPI no op, which are not normally used with reduction operators. Okay, so the problem with the remaining code is that the fences are collective. So this is not really asynchronous. All the processes are synchronizing at every time at the fence, and so they cannot just get a work descriptor, go off and do something with it. So WinFence is so-called active target synchronization. Active target synchronization means that the process that you put into or get from is still sort of involved with the operation, because it has to do the synchronization defense calls. But if you really want an asynchronous application, then processes that are not actively doing something should not be doing any sort of one-sided calls. Okay, that's where passive target synchronization comes in. And I'm giving that as exercises, but I'll just walk you through the code. Which one was that? Block fetch. Okay, so what is happening here? Okay, so this every process accesses the window just once. So let's see, there is the supervisor, no. So every process, and this is the relevant bit, every process puts a lock on the remote window, and it's an exclusive lock, so now no one can touch the remote data. Then you do a fetch and up, and then you unlock the window. Okay, so this would be one solution of doing atomic operations with locks as opposed to fences, but this is still not really the best solution for a really good solution. Let's see. For a good solution, you let every process put a lock on that window, but now you make it a shared lock. And now everyone can do fetch and up operations, and they are still atomic. So the difference between the two strategies is that here the lock and the unlock are immediately around the fetch and up. And so if you need to do a whole bunch of operations, you keep locking, unlocking, locking, unlocking. That is probably inefficient. And so what you want to do is put your lock and your unlock completely outside of your the part of your code where you are interacting with the remote data. And then you can do fetch and up. Oh, but now you've done an atomic operation, but the part that it hasn't done yet is coherence. And so you need to do win flush something. Yeah. If someone thinks this is tedious, I will not dispute that. Right, so you need to get your locking straight. You need to make sure you have atomic operations, and even with that, you have to flush your data to get the coherence straight. Why wasn't there a flush call in this code? Well, as soon as you unlock the window, the coherence is enforced. But here, the lock and unlock are very far outside of your communication episodes. Okay. And that's it for atomic operations. Yep. Okay, fetch and up. That, or gather, accumulate. No, what is the name? Get, accumulate. Yeah. So that's basically it. And let these examples function as a case study in how to do one-sided operations. Okay, well, let me just continue with the next slides, which are the advanced collectives. They should not take terribly long. So MPI 3 added non-blocking collectives. Normal collectives are blocking, so you know that if you do an MPI reduce and one of the contributing processes is lagging in time, then the root process at least will sit waiting until, so it's a blocking call. So you have blocking and non-blocking sends. For every send, there is an I send, receive, I receive, send, receive, I send, receive, which immediately return control, and they have a request object that you can use to track whether your indirect operation has been concluded. Okay, now we can do the same thing with collectives. So broadcast, I broadcast, reduce, I reduce. So yeah, for every MPI something collective, there is now an MPI I something, which has an extra argument in the end of the request object. Okay, so calls return immediately, just like with iSends. You get the usual story about buffer reuse. You cannot reuse the send and the receive buffer from your collective until after the wait call, and it takes a wait call to complete. So in that sense, I broadcast is no different from I send. They both take a MPI wait all, wait some, wait any. And just like you can start a whole bunch of I sends in a row, you can start a whole bunch of I whatever collectives in a row and then wait on the whole caboodle. Why would you do this? Well, the usual argument about overlap of communication and computation. But like I said, if processes lag, then this can remedy your imbalance, because now you don't have to wait on data to come in. You can post the I collective and then wait for the data to come in. Also, you can now have multiple collectives active at the same time in your network, and so maybe MPI implementations can pipeline them or do other clever things to get better network usage or better throughput. Okay, so there is a whole bunch of arguments why this might be a good idea. Yeah, I broadcast all the same arguments except for the request at the end. Sorry. So the overlap argument, for instance, suppose you're doing the that inner product is a reduction, and matrix times vector is probably something more localized. So you start your collective, you do your local matrix vector product, and then you wait for the collective, and then you add the whole thing together. So if you can split up your operations into, for instance, something localized or something send receive-ish and something collective, you can interweave them. Yeah, in iterative solvers for linear systems, there's often inner products and then norms which can use a different type of reduction. And so here you can have multiple reductions going on at the same time. You don't have to wait for the one to finish before you can start the other one. Right, so here is a sum and a max reduction happening at the same time, and then you wait for them both to finish. We don't do the exercise. Now, unlike iSends and iReceives, where you can do an iSend but catch it with a regular receive, or do a send and catch it with an iReceive, you cannot do that with non-blocking collectives. So you cannot do a reduction where, say, the root blocks with a reduce and everyone else does an iReduce to get the data out of the way. This does not work. It probably hangs at runtime. The compiler, of course, cannot catch this. Yeah, so I haven't tried whether this is actually efficient, but for instance, an all-to-all data transpose could, for instance, be implemented as separate scatters or separate gathers. So for every process, right, data transpose, every process takes its data and it scatters it over all the other processes. And so you have a loop where you go over all the processes and you do a scatter with that process as a root. So maybe this is efficient. I don't know. I haven't tested it, but and persistent collectives, this is new in MPI 4. So just like MPI 1, I guess, already had persistent routines. So you do a send init where you give all the send parameters, you get a request. Then you do a start with just that request, and then it evaluates that send. You do a wait. And so the request now has the information about the buffers and the target and the tag and all that. And so the fun here is that with the init call, MPI can do some internal optimizations. And so now with repeated starts and waits, it can reuse the internal optimizations of the start. That existed in MPI 1 or 2, and now you can do a reduce init or any sort of collective init. Yeah. Let's see, what am I doing here? Oh, this is a power method. So a number of iterations, you multiply, you do the same reduce and then wait, and then you scale your data. So yeah, if you have a high quality MPI implementation, then it will have optimizations for reusing buffers and whatever of persistent sends and collectives. So you may be confused between the two. What is persistent? What is non-blocking? They both involve requests, right? Okay, a non-blocking is, and they both involve a wait call. So they look sort of similar, but a non-blocking call is very ad hoc. If you do 2 of them in a row, the buffers can be completely different. A persistent call, you describe the buffers in the init call, and then in the start call, you just say, okay, whatever I just told you, do that now. And so it allows MPI to do some planning ahead in buffer management, etc. Okay. Oh, right, non-blocking barriers. So this is an MPI 3 non-blocking barrier. So yeah, non-blocking barrier. I've had people actually burst out in laughing when I tell them that there is a non-blocking barrier, because a barrier means wait until everyone is here, and non-blocking means and now don't wait. So what is the point here? Well, okay, a barrier is actually not defined as a time synchronization, but as a state synchronization. So if you hit a barrier, then you know that everyone has the same state in their program. And in practice, a barrier will also do a time synchronization. So the main use for a barrier is for timing purposes. But a barrier is a state synchronization. And so with a non-blocking barrier, which gives you, like any non-blocking routine, a request, you can do MPI test on that request and see, has everyone reached this thing? Okay, so suppose you have your finite element grid and a couple of processes decide to do a local refinement, and so they need to tell their immediate neighbors that something has changed about the communication structure. The problem is that only a couple of processes do updates, and so most of the processes don't have to do any sort of communication. So how would you do that? So the need is to communicate only if it's necessary. And okay, so how do you do that? Well, the processes that do the local update, they send the update information, and then they post a barrier. So they say, okay, I'm done communicating. Now, every other process looks out for update messages and it tests for the barrier. So let's see, what does that look like? So first of all, if I am a process that is sending messages, then I do sends. So in this case, it's a random send, but that's just because it's an example. And then, so only the processes that do sends do their sends, and then everyone posts a barrier. And now you do an infinite loop where you do the following. You test, is everyone at the barrier? And if you are not at the barrier, if you're at the barrier, then you stop. But if not, then you probe for messages coming in. So that's where you catch the messages that you are not sure if they are coming. So you have a loop where you test for barrier and you probe for messages. So, and you probe for any source, any tag. The probe tells you that there is a message or not. If there is a message, you absorb it, and then you again test for the barrier or you test for messages. Okay, so yeah, together this does the distributed testing, whether we're done with the local refinement. If you are not receiving anything, then you will get the barrier, and you know that you're done. This is a literature reference that I found. So it's called distributed termination detection. How do you draw global conclusions from local knowledge without doing collective operations? So the idea is actually quite old, before it wound up in MPI3. And that's it for that. And then someone was interested in big data. Yeah, it looks like we might actually, with the break, make it through all the material, because we don't have lab sessions. Okay. Yeah, some people want to send really large messages. I think I've heard of a case where MPI is used to send the actual executable to other nodes, or a executable. But we live in an age of big data, right? So large buffers happen, and at some point, the MPI committee discovered that they had declared the size of the buffer as an int. And yeah, so if you're on a normal system where your int is 32 bits, then you're out of luck after 2.5 billion, 2.1 billion elements, not bytes, elements. So MPI3 had kind of a hack mechanism, a couple of routines with _x, and MPI4 solved it for once and for all by redefining 190 or so MPI routines with a _c suffix. Okay. What's the problem? Well, you have your size t, so you can make a large buffer, but and you can send it, but the problem is you cannot tell MPI how big the buffer is, because the size has to be an int. Okay, MPI3 introduced a MPI count type, and in Fortran, integer of kind, MPI count kind, which was defined as big enough for an int, so buffers, MPI aint, which is for window sizes in one-sided, and MPI offset, which is used in MPI file I/O. However, MPI send and all that had in their signature that the count is an int. So MPI3 has a nice MPI count type, but you couldn't use it. In MPI4, this is finally solved. So now for every routine, MPI send and whatever, there is a send _c in C. So the C stands for counted. And now the buffer count is a MPI count parameter. So whole bunch of routines. Fortran, as of 2008, has fairly strict type checking on MPI routines. And so Fortran can handle this through polymorphism. So C has a sort of polymorphism, but that is not part of the language standard. It is per compiler, and so the committee decided against doing that. And so unfortunately, you have an MPI send and an MPI C. Fortran is a nicer language than C, and so it just handles it by having an extra overload. By the way, yeah, Fortran is a nicer language than C. That's not terribly hard. If you would ask me if Fortran is a nicer language than C++, then my answer would be a little longer. So if you are a C++ programmer, kindly look into MPL, message passing layer, which is a wrapper around the MPI library, and I rather like it. It's a good product. So it's a way of writing real idiomatic C++ 17 with MPI. Let's see, what are we doing here? So this is part of a ping pong code. Yeah, from 3 to 10. Set your buffer length to 10 to the power whatever. And so this is much larger than is MPIL header only. I believe so. I'd have to cheat and nope. Sorry, I cannot quickly. I think it is. Mind you, I'm not very much in favor of header-only libraries. They increase your compile time by something absurd if they are not extremely carefully designed. Anyway, part of a big ping pong, make a large buffer and then send that buffer with length being an MPI count. So you do a send C and a receive C. Okay. And that's why in my slides of the prototypes, I give both the send and the send C. The one has an int and the other one has an int MPI count for the. So there are a couple of routines that output the size of a buffer, and so in addition to all the transfer routines, there is get count C and get elements C, which tell you what is the size of your buffer. There's a subtle distinction between those two. Now, MPI3 had a kludge for doing this. So it was possible to send large messages even in MPI3. You did that by making a contiguous data type out of some modest size, like under 2 billion. And then you send a bunch of those block types. Okay, so block type is something modest size, and then you MPI send a whole bunch of them. So it was possible to send way over 4 gigabytes, and you can receive this. The problem with this is that the get count and get element could not tell you how many elements you received. And so if you realize that the MPI receive routine, the buffer count is not the size of the message, but it's the size of the buffer, which can be an overestimate of the size of the message, which is why you needed the get count. And in MPI3, you could not do get count on such a large buffer. So that's why there were a bunch of routines with an underscore X for extended. Yeah, this mechanism is no longer necessary. So as of MPI 4.1, which doesn't exist yet, this will probably be deprecated. So MPI 4 is, how time flies. Is it a year and a half old, or is it just a year old? I don't remember if it was ratified last year or the year before. Probably last year. It's fairly recent. But I have somewhere. Yeah. MPI 4 as of June 2021, and the only way to use MPI 4 is to install mpitch 401 from mpitch.org. Okay, did I just finish? Yes, I just finished big data. So let's take 10 minutes and then I will do sessions, graph topologies, and foreground bindings. 10-minute break. And then my colleague Amit will take over for the profiling and the tools interface.
Thank you.
Ben was asking what's my experience between the release of the standard and reliable widespread implementations. I've only recently become part of the MPI standards committee. So previous standards, I didn't quite notice as much. Bill Gropp is still involved in the standard, and he has been there from day one, and he leads the MPitch code project, and so if you're willing to install alpha releases of MPitch or just install it from the Git repo, then you can always get the latest versions. Reliable widespread implementations. I am actually not sure. So I don't know how long it takes the Intel MPI to be updated. I know that they pull from MPitch. There are people from OpenMPI, of course, in the committee, and so I'm sure that everything that gets discussed gets fed straight into their experimental code. In general, I think MPI, because it's a library, it's much easier to release than OpenMP. Features from recent OpenMP standards are much slower in making their way into the modern compilers. So yeah, that's about all I can say about it. I'm sharing my desktop again. Let's see, we did big data. Oh, let me quickly say something about Fortran. So yeah, Fortran was always a bit of a nightmare with MPI. The compiler couldn't even catch it if you forgot an argument, and you would typically forget the error parameter at the end. MPI 3 and Fortran 2008, there is supposed to be a module, so you say use MPI F08, and that finally makes the trailing error parameter optional. Yay. In addition, all the ugly opaque handles have gone away, and so things like a communicator are now a type. Let's see, requests are types, all the MPI whatever null things are now types, so you can no longer store them into integers. You have to rewrite some code in case you were doing that. MPI com data type error handler group info file op request status and win are, last time I looked, all the things that used to be integer and that are now type. One notable case in Fortran 90, status was an array of integers, and it is now also an object. And it used to be that you had named indexes into the array, and now they are fields. The compiler will regularly catch it if you make obvious mistakes, like you flip the buffer and the size. And it says there is no routine that looks like this. On the other hand, if you, for instance, let's see, what am I doing here? My buffer is a real buffer, and I say that it's a bunch of integers, then the compiler will still not complain. Where were we? Big data is a case of Fortran using polymorphism and overloads. So the Fortran interface is actually really nice these days, a lot better than the C interface. Okay, let's see, big data, we did atomic, collectives, we did shared. Some people were interested in the sessions model. So if we are entering a world where MPI and threading models are living together and we get very asynchronous codes, then you run into the problem that, okay, first of all, you cannot close down MPI and restart it. But also there is no thread-safe way to start MPI to begin with. Suppose you initialize two libraries in two threads, then um, for them both to say, is MPI initialized? If not, I do MPI init. This is a race condition. So there is no safe way to initialize MPI. So in the sessions model, every library has its own unique way of accessing the MPI library. So each library can separately initialize MPI. Okay, not literally, but okay. So what you have been doing so far is called the world model, and that still exists. So the world model is MPI init and finalize, or init thread and finalize, and having an MPI com world from which you to make subcommunicators. If you use MPI com spawn, you can actually get multiple com worlds, but the sessions model is completely different. So you can now have multiple sessions, and you can even have sessions and the world model active at the same time. So what is a session? Well, you have to create a session object. The session object then asks how many process sets are there. So that is determined by your MPI implementation, but the obvious sets of self and world always exist. And now you take a process set and you make a communicator out of it. It is conceivable that your MPI implementation makes, for instance, a process set out of racks in your cluster, or if you have two types of processes, make processors, turn them into separate process sets. Anyway, a session can interrogate MPI. How many process sets are there? And then take one of these, make a communicator out of it. And then you're up and running. Then you have a communicator. You can even create multiple sessions in one program run. But sessions cannot mix. So you cannot send directly from one session to another. That kind of makes sense if you think about libraries. Your program will use many libraries, but the libraries don't know of each other that they exist, and so having a message between two libraries doesn't quite make sense. Okay. Okay, so yeah, we create an info object. You could, for instance, set the thread level in the info object, or just use MPI info null. The relevant bit is that you have an MPI session object, and now you do session init, where you give it the info object, the error handler, and out of it you get a session. Okay, so this can immediately handle the case that you want in one library to be threaded and another to be not threaded. So you just make two sessions with different threading levels. And at the end of your code, you do a session finalize. Okay, MPI session get number of P sets, so process sets. So that tells you how many process sets are there. And there's always two of them defined. See the bottom line, MPI self and MPI world. And now, yeah, you can loop over your sets and get their names and their properties and stuff. The basic thing is that, let's see, what do we do here? Okay, there's a line missing. This thing is stored in a variable world name. Okay, so you have a session, and now you make a group from a session and a P set. So you have a session, a name of a process set, and from it you get a group, and now you create a communicator from a group. And then you have a communicator, and now everything is the way it always was. You can delete your group, and etc., etc. And then you have a communicator, and you can run your library. You can have multiple sessions. So what am I doing here? Multiple info objects. And I create 2 different sessions. Oh, right. So here, for instance, I make an info object for a single-threaded library and for a multi-threaded library, and I init the sessions. Okay, I want to show a little bit of code that uses this sort of in practice. So this is C++. I make a library object, and every library has its own communicator and its session internal. Libraries is why you had the MPI com.dub routine. If you have a program that runs in com world and you have a library that you tell, okay, here's your communicator, you don't want your program to catch library messages or the other way around. And so that's why com.dub existed. So you would give your library a duplicate of the world communicator. This is a slightly different way of approaching it. So let's see. I hope everyone speaks enough C++. So this is the constructor. So that's the call for creating a library. So no info init session, and that you store in the session that is in your object. World name is npr-com world. You make your world group. You create a communicator from it, and you free the group. And now your library object has a MPI communicator. So now your library can do whatever it wants to do. So there is a not further specified compute routine. Okay, so here's a main program. I create 2 libraries. Yeah, this is a toy example, right? I create 2 libraries, and then separately I use the world model for my main program. So com world, and I do my rank and size. And now I do a computation on library 1 and a computation on library 2, and nothing interferes with each other. The libraries have their own session, and so they have their own access to MPI. What are the cases where you should or shouldn't use the session model versus the world model? Right, Eric says, we currently have the top level model produce communicators for the lower level components. We could use the session. So the main problem that was solved with the session model is that now a library can actually thread safe initialize MPI. So I guess if you have a not quite hierarchical structure to your code, then a library may want to initialize MPI, and it may want to do that anyway because right, this info object can specify things, and then you have the default error handler. So yeah, the main motivation behind sessions, at least according to the person that's been the driving force behind it, is the thread safety. We've been doing hybrid shared distributed, OpenMP, MPI, the shared memory features could allow us to do everything in MPI. Okay, that's a different question. I think I'll save that one, Eric, your second question. If you're happy with a hierarchical way where where you give a communicator to a library, it makes a COM-DUP of it, then you don't immediately need the sessions model. The future will have to show whether this really fulfills a big need. And of course, the flexibility of having process sets that are defined by the implementation. So that makes it much easier to deal, for instance, with two different processor types. At TAC currently, Stampede 2 has 3 different processor types. It's hard to make a job that spawns multiple, but it would be possible, and so conceivably an MPI implementation would handle that. Okay, sessions. Partitioned communication. Okay, this is again looking to the future. So you make partitions. I'll just fly over this, and now there is a psend. So you have a buffer that consists of parts equal all of a certain size, and now you have a buffer that is that has partitions, and you can do the following. So just like with persistent sends that already existed, you have your init and you start and then you wait. But now the started message can, so you have a call that fills up part of your buffer, and now you say, okay, part IP of the message is ready. So this is possibly a great idea for hybrid programming. Now different threads can together construct a message. And so MPI is now at liberty of either waiting for the whole message to be finished and then sending it, or maybe pipelining the bits of the message through the network. So to MPI, it looks like one buffer, but threads can, at their own pace, fill it in and declare, okay, my bit is ready. And likewise, there is a partitioned receive. I'm not using that very sophisticated, but just like there was a MPIP ready, which says part so-and-so is ready. There is a P arrived where you can ask, is part so-and-so of the message ready? Did it come in? And that's about all I want to say about partition. So this is again for hybrid models with MPI and threading. The final topic, okay, Eric. Now you were asking about shared memory. What are the advantages? The advantages is that if you use MPI OpenMP as a hybrid, you get a next level of Amdahl's law. So in each process, the efficiency becomes limited by the bits that are not OpenMP parallel. Whereas if you make everything completely MPI, or as some people call it, MPI plus MPI, so MPI between the nodes, and then MPI shared memory as such inside the nodes, you conceivably could have a higher efficiency. Yeah, it's kind of hard to answer that question in general. You'd have to look and see what feels the most natural to you. MPI has a advantage over OpenMP in that you don't have race conditions. So if you use your shared memory only for reading from shared memory, then you have the combination of efficiency of data access and still no race conditions. It's hard to say much in complete generality. The last topic I wanted to do, and I have 10 minutes for that, and then my colleague Amit takes over, is process topologies. So I'm sure you've run into Cartesian topologies, which were already part of MPI-1. MPI-1 had a graph topology, but it was not very usable because one or all of the, I don't even know, but basically someone had to declare the whole topology, and so that puts a limit on scalability, and it's kind of a headache to do that. So MPI-3 has distributed graph topologies where each process declares only its own part of the graph, or at least that is one of the possibilities. So it's a scalable graph topology specification. MPI dist graph create, dist graph neighbors count, and then with graph topologies come a new category of collectives, the so-called neighborhood collectives. Okay, why process topologies? Processes don't communicate at random, at least in most codes. They have some specific neighbors, and so if you can tell MPI, I am only going to be communicating with this process, then MPI can optimize for that. Just in terms of your code, expressing something in terms of, let's say you're modeling a 3D Cartesian grid, and you arrange your processes in a 3D grid, is a more elegant expression than having to translate your linear process ordering into 3D coordinates. So it's an expression of your problem that is closer to your application. And conceivably, MPI can optimize for the knowledge that you will only be doing certain communications. I'm not sure if there are any MPI implementations that actually do this reordering. Process reordering, yeah. So like I said, MPI-1 has a Cartesian topology and a graph topology that should not be used anymore. MPI-3 graph topologies are scalable, and they come with neighborhood collectives. Why neighborhood collectives? So why neighborhood collectives? If you do a 5-point stencil, then usually this gets reflected in your communication structure, and each process communicates with 4 neighbors. And so you are really gathering that information. You don't particularly care in what order the data comes in, as long as it's all there. And so you have your halo region, and you can, the usual finite element and finite difference stuff, right? So that's why you want to express this not as a sequence of sends and receives, but as a gather. What is the problem with sends and receives? Okay, you have to spell it out. So let's say we have a 2D grid, and let's say that each process communicates down to the right, up, left, or whatever order. So because there are 4 compass directions, it can be done in 4 steps. Okay, so in step 1, everyone is sending to their down neighbor, and the bottom processes are engaged in. Now I don't believe my own figure. Anyway, so processes are active, and then in the next step, one process is blocked because it cannot be sending because all of his communication channels are already busy. I'll have to take another look at this figure. It was inspired by something Bill Gropp once put on a slide. Anyway, so by spelling out the sequence of sends and receives, even if they are non-blocking, the network card will probably do it in a certain sequence, and that may lead to blocking. So it may lead to processes missing a turn in the sequence of operations. Also, if you don't spell it out as sends and receives, then collectives can use pipelining. So if you know a bit about how collectives are, normal collectives are implemented, you know that recursive doubling is not always the best strategy. If you're broadcasting a large buffer, then you don't use a tree, you do a scatter followed by a sequence of rings. Okay, so if you formulate this as a collective operation, then MPI is free to do that sort of pipelining and different ways of moving data that are more efficient. Okay, this subject comes with, it's a little tedious to do this, so I'm not going to go into a great amount of detail. A distributed graph create, so you have your old communicator. Each process calls this. Each process calls this, and each process says, okay, I know I am going to specify the communication pattern for a number of processes. So it is possible that one process specifies the whole graph, but the more logical thing to say is that each process says, I am going to specify one process, namely myself. Okay, so you have an array of sources, which is probably your own rank. Okay, and then you have an array of degrees, which is then your out degree, and the array destinations, which is what processes am I going to be sending to. This can be a weighted graph, so you can indicate that certain directions are more important, info object, and you can tell MPI you are allowed to reorder this. Okay, and then there is a bunch of routines like neighbor all gather, where just like a normal, in fact, this is entirely like the normal gather, send buffer count data type communicator. So it looks like a gather. The only difference is that your receive buffer is has a size that is the degree of that node times the receive count. So it's not the global length, but it's the length of what you get from your neighbor. Okay, so the data when you do a gather, the data in the receive buffer is not written in any sort of process or ordering, and so you need to have a routine. How many neighbors do I have, and what are they? And that tells you what the data is in your. Okay, and that's what I'm going to leave it at this. Okay, so remember about graph create. Every process tells MPI how many processes do I communicate with, and then you can do a gather by gathering data from those neighbors. Okay, those are neighborhood collectives, and again, something that on a large, on excess scale may lead to increased efficiency. That's it for me, and that leaves half an hour for my colleague Amit. Any questions? Okay, Amit, I am stopping my share. You should have permission to take it over.
Sure, thanks, Victor. So good afternoon, everyone. Am I audible? Victor, can you confirm I'm audible?
Yes, you're audible.
Yes.
Oh, thank you. Thanks.
You're audible.
Hi all. So in the last part of this MPI session, we will be covering about the tools support in MPI. So Victor has already introduced a lot of new functionalities which have been added in MPI 3 and MPI 4.0 standard. But apart from that, there are requirements in terms of performance when you want to see how your application runs on a given cluster, and what tools or what features you can leverage from the MPI to identify if there are any bottlenecks or to identify any errors when you run or build your programs. So this is the topic of the discussion now. And as you know, performance is the fundamental part of high performance computing. We use MPI just because of the performance we get from the MPI programming. And the performance of an application depends on several factors, including hardware, what hardware are you using, what is your CPU architectures, what is your interconnect architecture, how much memory and other devices, how much memory is available on the systems. Apart from that, the software libraries, like which MPI library are you using? Are you using MVAP2 or Intel MPI or Open MPI? So every MPI has a different way of implementing the MPI functions. And then another thing is like every MPI provides a large number of parameters to tune them on a different clusters. So if an MPI library is optimally tuned on a cluster, it can give you quite good performance compared to the non-tuned MPI libraries. So these are the parameters, these are the factors which can affect the application's performance. And we have seen a lot of users complaining about running applications on a different cluster and then coming to the tech systems and asking about the performance. So at that point of time, we try to identify the issues, why their application is having issues, and if MPI can solve some of the issues. So understanding performance is very necessary, and let's take a look at what are the supports available in the MPI standard. So PMPI is the oldest interface which has been there since the inception of MPI in 1994. And PMPI is very basic functionality which can give you a performance of different MPI routines which you have used in your program or an application at a higher level. This information might not be useful, may be very abstract, but if you want to dig deeper into the MPI implementations, so in 2012, MPI tools interface was added to the MPI standard. And this was added in MPI 3.0 standard. And there are two implementations. One is CVAR, which is control variables, and the second is PVAR, which is performance variable. So control variable are the variables which you can tune, which you can change to tune the to select a different implementations to select the different algorithms from an NPM implementation, and you may get a different performance with the same MPI routines. Performance variable are the variables which can give you a state information, like there are several thousands of variables defined in MPI implementation. So what are their states and how their behavior is changing over the time? You can use PVARs for that. But if you want to change the algorithms, or if you want to make change right at the time when you are running your application, so CVARs are those variables which can change the behavior of MPI implementation. In the latest MPI 4.0 standard, which was published in last June 2021, so a newer interface has been added, which is called events, and events give you even final granularity of information, like when exactly certain variables or certain states or certain objects have changed their behavior. So this was not provided by the MPIT variables like PVAR, because PVARs provide you information at a global level, but events can provide you even final granularity of information, like when exactly or which process those variables have changed, or they have taken a newer value. So let's take a look at all of these tool support. So as I said, PMPI was introduced just at the beginning of the MPI standard. It is the oldest interface which has been used by a variety of tools or debuggers or character checker tools. MPIP is the MPIP, which is from LLNL, is very nice tool which has been developed based on the PMPI interface. Similarly, we have Tau, Umpire, etc. To control whether you want to do profiling or not, there is a variable which is called MPIP control, which can be turned on and off to turn off the debugging, to turn off the profiling. And this interface, though it gives you, you can get the information from the MPI, but it doesn't specify or it doesn't mandate what information can be collected. It all depends on the tool which has been written using PMPI interface, what they want to collect and give it to the user. So there is no mandatory requirement for a tool to collect the information. They can collect as much information as they can, or they can just provide you a small set of information from using that PMPI interface. So how does it work? Basically, we have an application on one side, and then there is an MPI implementation such as Intel MPI or MVAP or OpenMPI. So in applications, you call MPI functions just like MPI send. But when you look at the implementations, all the MPI functions which have been exposed by an MPI implementation, they are represented by a weak symbols. Now, what does it mean? So when you define a weak symbol, when you define a weak symbol to any function, what does it mean? If there is a stronger definition exists for that function, then that function would be called instead of the weaker definition. So as a default, MPI implementation defines MPI send as a weak function, which points to a wrapper function which is name shifted with PMPI underscore. And this is the main implementation within the MPI library. So if you want to write a tool using PMPI interface, as you can see, this tool can declare that MPI send function again, which is a stronger definition, strongly declared symbol. And when this profiling library is linked with the application, since it defines the stronger definition of MPI send, so instead of MPI send, which is called by application, to be called from the MPI implementation, here it is called by the profiling library. And within the profiling library, MPI send itself, it calls the MPI send function, which is the main function defined in MPI implementation. But before that, it can do a lot of profiling processing. For example, before PMPI send, you can start up a timer. And after the PMPI send, you can stop a timer. And it can give you a time spent in PMPI send operation. Similar things you can do is you can check the state of the buffer, like what content it has. You can even change the buffers if you want to simulate the end conditions or boundary conditions. You can also check what are the number of, how many such variables have been transferred. Who was the sender? Who was the receiving? Who was the which process is the receiving process? And similarly, you can identify other information like data types and etc. So PMPI information, using PMPI, you can collect who are the senders, who are the receiver, what was the buffer size, what were the buffer contents, how much time was taken by PMPI library. But as you know, this can be PMPI can be used only for the functions which have been exposed by the MPI implementation. But within an MPI implementation, certain other functions are available which are not being exposed by the PMPI interface. So that is the shortcoming of this PMPI interface. Like the first is it does a shallow profiling with standard MPI operations. So only operations which have been exposed by the standard, they can be profiled. Not any other implementation, not any other functions which are there in the MPI implementation. Second, since it is based on the concept of stronger and weaker symbols, there can be only one strong definition of a weaker symbol at any time. So what it means is there can be only one profiling tool which can be used along with the MPI implementation. So there is no in-depth information is exposed by this interface, and there is no extra. So the external view or the abstract view of MPI operations might be insufficient for lots of developers or MPI users. So and as you know, MPI library supports hundreds of parameters which we cannot profile using this interface. I just want to show you one tool which is called PMPI, and showing what kind of information it can collect. So as you can see, this PMPI is developed by LLNL, and this interface is pretty nice in terms of so it can tell you how much time has been taken by a program, various details about the program, and it can also give you per rank information, like how much time was spent in application compared to how much time was spent in MPI operations. For example, this program shows like 2% of time was spent in MPI operations per rank. Then it can also tell you which of the MPI operations have been called, at what pace in the program they have been called, and then you can also identify what are the top 20 operations, MPI operations, how much time they have been taking, and what are the number of times they have been called. For example, this ISN operation has been called 71,000 times, which has taken almost like 16% of MPI time and 1% of application time. Apart from the timing information, you can also collect the message size information. What are the top 20 operations which has sent which has communicated most of the MPI data. So, and then there are several other details, and these are the functions. Let me show you. These are the MPI routines which can be profiled with MPI. So just these routines can be profiled with MPI, but if you want to know more about the details, then we have to use some other interface. Then within the MPI 3.0 standard, the new functionalities have been added, and these functionalities were added to cover the features which were not there in PMPI. So it gives you an extensive performance information in very reliable and portable manner. And there are two interfaces which are CVAS and PVAR. And again, just like PMPI, there is no restriction on the tools to provide the certain information. It all depends on the tool or profiling libraries, what they want to get from the MPI library and want to show it to the user. So the general workflow of profiling library is, well, you have to initialize the profiling library and then get the capabilities of an MPI implementation, what they can provide us through PVAR or CVAR, like performance variable and control variables. So it depends on the MPI implementation as well, what they want to expose. And then once you get those capabilities, then you can create some sessions, and within those sessions, you can measure the performance variable, timing information, or you can access the variables, and then at last you have to finalize the tool. So the session information, like you also create sessions within the two profiling libraries, But this session is different from what Victor has told you prior to this presentation. So this session belongs to just the profiling library sessions, and they are meant to provide you information so that, like, if you have a profiling library which and different components of profiling library are accessing different variables in an NPI implementation, then you need a concept of session, because in a session, if you are measuring the performance, if you are measuring the state of a performance variable, then that variable within a session can give you a consistent value. So therefore, create a session, and multiple components of profiling library can create multiple sessions, and each session can measure different performance variable. And starting and stopping those performance variable doesn't impact the starting and stopping of performance variable in other sessions. So these are the functions. You can always look to the standard, like NPI, what are the syntax for these operations. So NPI init thread is there to initialize the thread library, and corresponding to that is a finalize operation, which is called at the end. Between that, you first identify what are the different number of performance variable and control variables are being exposed by the NPI implementation. And once you get all the variables, then you can call each variable. You can get the information of each variable using the get info function. So get info functions provide you what is the name of that variable, what is the name, length of that variable, length of the name of that variable. And then verbosity provide you basically to which user, whether that performance or control variable is having a meaning for a user or for a tuner library or for an NPI developer. So basically, it segregates all the variables in 3 categories, which may be which may be of interest to a user or a developer or to a profiling library. Once you get the verbosity, you can also identify the data type of that performance variable, whether it's integer or a float or some other data type. Then there is a description. Just an example here, there is a variable in Intel MPI at the index of 184, which shows you CH4 OFI enable AM. So what it gives you, if it is true, it enables OFI active message support. So this is the variable which is there in the Intel MPI. And this verbosity is for the user basic, but it means it is meant for the user and in all the verbosity levels which are above the user. Then it doesn't bind to any object. So by binding means each variable can bind to a object within the NPI implementation. It could be at a global level. The variable has a meaning for all the processes, but it might be defined for a communicator level. So the variable can mean for one communicator and not for others. Then it can be of data type that it can be associated with a certain data type or error handlers, file handles, group reduction operations, request, window one-sided, info object, session with, etc. Then once you get the association, then there is another concept which is the scope of a control variable. So what it means, when you want to change this control variable, whether that variable can be changed. What it means, if it is a constant, we cannot change its value, or it could be read only, which can be defined within the implementation, which can be used in NPI implementation, but a user cannot, or a developer cannot, or a tool user cannot change it. Then another scope of the control variable is the local, whether it has a meaning for just one process or for a group of processes. And if it is for a group of processes, does it has to be equal across all the groups? And if it is meant for all the processes, then does it has to be equal for all the processes within an NPI run? So control variable, to access the control variable, you first get a handle to that, then you can read and write those values, and at last you can just free that variable. The syntax of using the control variables is given here. And I'll just want to show you a couple of programs which shows how you can use the print, how you can get the print how you can print all the control variables. And if you want to change what happens, like if you change how the performance changes. So let me go to the control variable program. I just want to demo. I have made a program which shows you what are the list of, which shows you all the performance control variables exposed by MPI library. So here, as you can see, almost like 620 performance control variables have been exposed by MVAPish2. And there is another program. I don't have time to go through that, but I just want to show you. If you change, like there is an algorithm bcast within the MPI operations. There is an operation MPI bcast for which each MPI library, whether it's an Intel MPI or MVAPish2, there are almost like 15-20 different implementations. And if you just change the MPI, if you just change that algorithm, the performance might be significantly different. So if you just, let me just run this program. So in this program, I have used the MPI use bcast, MPI CVAR use bcast, which is the control variable exposed by the MVAPish2. And this variable doesn't bind to any object because it's related to the MPI bcast algorithm, and it has to be equal throughout all the processes within a communicator. But when I use value equals to 4, which is basically the topology of a binomial algorithm, the single broadcast took almost like 510 milliseconds. But when I change the algorithm using this control variable to 9, which is basically topology of a shared memory based broadcast, it just took 83 microseconds. So this shows how you can use these control variables to change the MPI implementation, behavior of MPI operations within a given MPI implementation. And this change could be a lot of performance impacting applications. So sometimes if you don't find like certain algorithms to work, so you can always use these variables to to specify different algorithms that you would like to use from the MPI implementation. After the PVARs, after the CVARs, let's take a look at the PVARs. So PVARs are basically the performance variable which provide you more the insights about internal performance, insights about the states, various states or various data structures or various various objects which are there in the MPI implementation. This could be like states of MPI, whether MPI is in waiting mode, block mode, or receiving or not active mode. Then we can also look at various buffer sizes, what are their length, what is their occupancy, and how they are changing their occupancy. Then there could be some memory footprints, some module times, like there are some like multiple algorithms, but within those algorithms, there are multiple sub operations or sub modules, how they achieve, what is the time spent in those sub modules. Then you can also get the information like polling count, retransmission count, etc. Just an example we have shown from the MVAPish2 library, there is a number of virtual buffers available. So it shows you how much buffers are available at a given point of time. So PVARs are classified in multiple categories. They basically classify like based on their syntax, what are their data types, what is their behavior, whether they can overflow or not, or what initial values they can take. So they can belongs to a state, whether it's active or passive or something else. They can represent a level, like what is the resource utilization of a given variable at a time. They can represent a resource size. They can represent percentage utilization, which can be of the floor data type. Then they could identify what is the highest watermark. What was the highest value obtained by their performance variable. Similarly, we can get the lowest watermark. What was the lowest value? They can also represent a counter which increments in a increment of 1, whereas they can also be represented as an aggregate, which is basically increment in any arbitrary order. Similarly, PVARs can be defined as a timers, or if none of these classes is sourced to any PVAR, then they can be specified as generic. So as I said, PVARs are always accessed within a session. So first you have to create a session, then you have to get a handle to that PVAR, and then if the PVAR is not continuous, it means you can start and stop that PVAR. So you can start and stop if it is not continuous in nature, and then within that start and stop, you can access the function, like you can read a PVAR or write a PVAR. You can even reset it or read reset if it is of not of, if it's atomic, if it's of atomic nature. So there are certain syntax which you need to use, but you can always refer back to the slides or from the MPA standard. So there is another exercise for PVAR information. I don't have time to go through that, but these two exercises show, this exercise shows you how you can get the performance variable information from a given implementation, and how many, and you can also get certain information like there is a PVAR which is basically which represent a collective broadcast algorithm for which uses shared memory and zero copy mechanism. So it can tell you how many times this implementation has been called. Next is the variable categorization. So all PVARs and CVARs can be categorized in multiple categories. So basically, this categorization helps us to organize the information within a tool. So in a MWAP2, you have like almost like 11 categories for 2.3.5 implementation, and these categories might belongs to whether the PVARs belongs to or CVARs belongs to a debugger or developers, or for the communicators, whether they have a meaning for memory, etc. So this is just for the representation within a tool. Last, in MPA 4.0 standard, which was published last June, MPA 4.0 standard has introduced events. Now, we have discussed about the PVARs and CVARs. So PVARs give you information at an aggregate level. So it can tell you how many times or what is the buffer occupancy at a certain time. Or it can tell you how many times this operation has been called. But it cannot give you the information like exactly at what time or when that condition has triggered, or when that buffer has reached above a certain threshold. So if you want to identify the information at final granularity at per instance basis of a application run, events could be more helpful. So events, how it works. So basically, each NP implementation defines at like what events they support, and it's a user responsibility to define a callback functions which can be called by the NP implementation when certain conditions is reached. So whenever a certain condition is reached in the NP implementation, NP implementation calls the callback function which are registered by a user within the NPI. So events can give you that at that level of details. So for events, it can give you like so the function APIs which are being there for the events are basically what are the events supported, who are the sources of those events, how to handle those events, how to register the callback functions from the tools, and then reading and writing the information within the event. Events are recently introduced. They have been added in MP standard, but I so far haven't seen any event, though the support is there in the MP implementation, but there is no such event which is exposed by the MP. I think with the with couple of days or maybe months, MP implementations will add certain type of events at different steps of MP implementations. Like they will tell you what are the events that can be exposed, or they have been exposed, and then users can use those events to identify various information. Even if MPA standards do not, if MP implementations do not have that, but if you're using the latest MPA 4.0 standard based MP implementation, you can also add your own event functions, because support is there. Then it's just a necessity of where that support has to be added within MP implementation. So this is a newer one, and I would like to see various implementations using that event interface to expose different information. So as a summary, PMPI was there as a de facto standard for more than 2 decades. And then MPIT has provided us comprehensive profiling information, and further events have been added in the MPI standard. There is another interface which is QMPI, which basically is a newer improvement of PMPI. So which basically adds like multiple tools can be added as a QMPI. Multiple profiling tools can be added. Whereas in PMPI, there was just one tool which can be linked to the application, but QMPI, multiple tools can be added. But that tool is still under discussions and might be added in next set of standards. So newer features make profiling even more robust and portable. And I just feel there is just one minor issue is that different tools use different implementations use different way of naming performance and control variables, which is not consistent across variety of NPI implementations. That is the only minor issue which is there in the profiling tool. Otherwise, these tools are these profiling interfaces are very useful and can help one to debug the profiling issues within NPI programs. So that's all from my side. Let me see if there are any questions. So I don't see any questions. Feel free to ask any questions regarding the tools interface, and I would be happy to answer them right.
Thank you very much. Any questions out there? I threw in one I had.
So yeah, Ben has asked one question about the recommendations about the tools. So most of the tools like MPIP, and there is another very sophisticated tool, Tau. So if you just want to start debugging or looking at the top level information, start with the MPI interface and use the MPIP tool, which can give you a lot of information, top level information regarding the performance of MPI. Like it can tell you what are the different operations which have been used by a program, what was the time span, and how much those operations have been called. It is very useful for all of us, and I always recommend it to my users. And then if you want to go more in-depth details, then Tau is a tool which you can use. Dr. Samir Shinde from University of Oregon, he has developed that tool, and that is very sophisticated and can give you a lot more information. There are some paid tools like VTune is there from Intel, which is also quite useful. So it depends on what kind of profiling you want to perform. You have free as well as paid options in there.
Are there any other questions out there? Well, it does look like we've hit our time. I really appreciate and like to thank the speakers. It's a very informative afternoon. I certainly learned quite a bit. So thank you very much. And
thanks, Ben.
For all the participants, hope to see some of you back tomorrow.
Sure.
Okay. Bye-bye.
Bye.